PC has restarted. Let me get my Windows set up here for a sec. Okay. Okay, so that's going to be loading. That's going to be loading. Okay, so I was talking about how I was looking into rewriting my terrain algorithm into a shader, which is just going to be an absolute misery, and I'll probably have to do it bit by bit. Each line here is like a separate step of the generation process. Blend between different potential neighbor, chunk, biome, zone noises. So different chunks can have different noises, and if it does, then I'm going to need to blend between them to make sure that they match up. And then I apply a height curve to it, because it's all values between 0 and 1. Apply the height curve, you know. Apply altitude blending, so in the world map, there is an altitude to each chunk, and so I want to kind of increase, you know, because all chunks, like, theoretically, we just have noise on a flat plane. And then if there's an altitude in either direction, I would want to lerp between that. And then, what is it? Blend to neighbors, noises. Oh, I blend again to apply the height curve and multiplier. I forget why I need to do this twice, but that's how I got it to work, and I'm going to stick with that for now. And then applying the border mountains. I think there's a big performance impact from the border mountain. And maybe I should look into kind of tabulating how long each of these steps takes to figure out which ones I should move into a shader first. But like moving each of these functions is like kind of a fucking heavy function. That would be like, how do I pass a spline to... I guess I would have to iterate through and get the closest spline point to every vert, and then pass that in as a map, or of an array of floats to the shader. So, yeah, the whole thing is going to have to change pretty substantially, I think. And so I think maybe I'll just, bit by bit, I will replace that rather than just trying to rewrite the whole thing in there. And we'll take a look at what the shitty implementation looks like. So it's really just a height curve applied on some noise generated from the material. But yeah, I was just kind of doing a little bit of research this morning, because I think before I move everything to a shader, I think I'm going to need to think about how I'm going to do the 3D noise stuff. It's going to be interesting. There's a lot to consider there. A lot of different methods that can be used. I think I will end up using Perlin noise, as I've said before, or Perlin worms for caves. But I need to figure out, like, am I still going to just use a height map? Or am I going to just use 3D Perlin noise does not create good terrains. Dude, I hate when things just freeze up and just... Unreal Engine, can I use you yet? Like, what is happening here? You are incredibly slow. What a nice coffee here. Nice iced coffee. Okay, well that's just gonna, you know, okay, there it is. There it is. Okay, let me make sure I have the material plugged in here. I do, okay. Yeah, let's look at what this little material outputs for terrain. Okay, yeah, I do need to do the height multiplier. There we go. So right now we're just checking out what like a pretty naive terrain is going to look like generated by a material without all my extra bells and whistles. Yeah, it's and I'm doing from -1 to 0 here, so there's a lot of water. So maybe I can adjust that a little bit. And yeah, I don't have the biome blending on, so these aren't going to match up across biomes if they have a different set of noise. But yeah, I mean, it does a pretty decent job, right, of creating some terrain. Quite bumpy. But, you know, I can always change the parameters around to change that. Now let's go from 0 to 1. Why is this so goddamn slow? Go from 0 to 1 and see what that looks like. But yeah, this doesn't have like the biome blending and the border mountains and the altitude blending and stuff like that, so... But it doesn't take upwards of a minute to generate the whole thing anymore, so that's cool. Dude, why is Unreal... Dude, I swear, it runs so slow at the beginning. I don't understand. I don't understand what's happening. Oh, nice. The anti-malware service executable was just going burr. So that's why that was running slow. Where am I? There I am. Okay. So this is from 0 to 1, so now there's a lot less, there's like no water. And this is supposed to be, I think this noise is supposed to be like my swampy noise, so that's why the altitude curve, or the height multiplier curve isn't very strong on the red zone here. These ones match up, different materials, but they match up because they're the same noise. So yeah, what did that generate in? It says 44 seconds, but I know that's not true. Well, that's probably because the anti-malware service executable was slowing me down quite a bit. So yeah, theoretically possible. I like this noise. It is very bumpy. I think I would want to smooth it out a little bit, but yeah, this is what that ended up looking like. Let me do a raw run here. I want to see without the anti-malware service executable. Just absolutely cooking me. Yeah, that was 5 seconds. Took 5 seconds to generate the terrain, as opposed to a minute with my old algorithm. So yeah, way faster, way faster. Rewrap this in a condition just so when I switch back to the old way of doing things, I don't because I have to create a render target, and then I'm like writing the material to that render target, and then I just like sample I have to get like the pixel data, so I don't want to do all that extra stuff, the normal flow of things. But yeah, I was looking into the shader stuff, and it's going to be pretty complicated, and I was looking at these functions that I wrote, and yeah, translating some of these to a shader is going to be absolute misery. I think the border mountains are probably going to be well, what's also going to be hard is blending to neighbor noises, because I'm using like a callback function in there, or rather blend to neighbors weighted average. Yeah, I'm using a callback, which like I don't think you can do that in a shader, I'm pretty sure, so I'm gonna just need to like change how I do that completely. I was looking at the Unreal Engine global shader thing. That's what this is going to be. I guess you can create like structs and stuff, which would be really nice. Yeah, I think I just need to figure out what I'm going to do for the 3D stuff, because that's going to affect, like, I'm just thinking down the road for like the future of this terrain algorithm. Like, that's so fast. Like, that's crazy fast. If I can get it that fast with all the other stuff that I'm doing, that'll be insane. That would unlock so many things for me. It's like I want the colonists to be able to dig, and the players to be able to dig through this and stuff, and I want tunnels and things, and so I need to think about like how all that works, because right now it's all just height map based, 2D essentially. So it's pretty difficult to join those two worlds together, which is I think what I'll have to do. Because the 3D noise doesn't really create very good like landscapes. You can create some really interesting like caves and valleys and stuff like that. And I'm thinking what I'm going to do after watching some of this guy's videos that I think I'll probably continue watching on the channel here, but 2D height map, and then I'll use 3D Perlin noise a little bit, maybe just for, because that can create, it just creates like very globular noise, not very like coherent noise or anything like that, like just kind of random globs. I think maybe I'll have like a bias for each zone as to like how much that should cut into the height map, because it's also going to generate above the landmass, like in the air. Essentially, it would just be, there would be a bunch of bits floating in the air. And so I'm gonna need some thresholds or like some levels to like, as to like how to apply this 3D noise. And I think when it intersects with the landmass, you know, I'll have some bias to apply to each zone. Like, you know, maybe a very flat zone wouldn't have very many of these subtracted from it, which would create like little like cavey craters. And maybe I should actually watch that. Oh great, I restarted the video.
Generation.
Let's watch this though.
This talk is about infinite worlds, or ridiculously large worlds, and all the problems.
Let's go back to the previous video actually. Ads. Like, you guys can actually see like what I'm talking about. Let me try to find the 3D noise part.
4 of 6, digging with Perlin worms. Not just Perlin worms, but that was the coolest sounding part of what I'm talking about.
Here we go.
A star through Perlin noise.
So he talked a bit about like Perlin worms and stuff.
What about 3D caves? So we can carve them using 3D Perlin noise. That again is just like Perlin noise, but you plug in an X, Y, and a Z. And this is what it looks like.
So yeah, this is the 3D noise I'm talking about right here. Like, it's going to generate things in the air. And that's what we're looking at here. But it's also going to generate things underground. And so you'd only want to take the stuff underground or intersecting with the terrain, in which case you would need that height map generated first to know where the terrain begins and ends.
In space. So these are just sort of the noise of 3D noise. And I can set a different threshold to say if you're above a certain threshold.
I have it set to 1.5. I'm going to turn that down to like 1.25. He also needs a volume boost, I think.
You're a cloud, or whatever these are, marshmallow. If you're below a certain threshold, then you're not. But I could easily imagine that those are the shapes of the caves that I'm going to carve out of the ground, right? Yeah. And that's what this would look like. Nope. This would, nope. This would look like.
So you can see right here, like, how it can kind of get subtracted from the surface of the terrain, but then they also might exist underneath the terrain as well. I think I'll probably have some bias for that, for like how many like pits I want.
So now I'm like eating these.
But these aren't actually like, it's not actually going to generate like a cave system. They're just like little globs, which can be, you know, I think that paired with Perlin worms can actually be pretty interesting. So there can't just be like random open globs underground, and then maybe the Perlin worm intersects with that, you know.
These clouds, instead of having the sky, I'm eating them out of the ground. And I'm eating them out of the sky too, they're just not doing much, right? So if I look around, I can see there are some moderately interesting caves that are produced.
Like, see, that's not bad.
And I'm going to just fly through the walls because this is just a demo. And I can actually find some that are pretty interesting and compelling. I apologize if I make anyone sick. Like this section goes through here. However, the Perlin 3D Perlin noise doesn't always close in on itself and doesn't connect through. It doesn't like lead anywhere. Not that caves have to lead anywhere. So Minecraft doesn't use that. Minecraft uses Perlin worms to carve its caves. Oh, there we go. This is not a bad one. So you can see, you can get some pretty good results by carving those white cloud blobs, just carving them out of the landscape instead.
It's like now I have to think about, because like all I'm doing right now is I generate this height map array, this 2D array, and then I pass that over to, I mean, this is kind of a simplified what I'm doing. Pass it over to, God, why did that, I typed in the exact name of the class, and it's like, no, you want this other thing. Like, why is that what I would want? No, I want mesh generator.cpp. And so the mesh generator, this is what actually creates like the data for the procedural mesh component. And so we're going to iterate over that same height map. Like here's the height map essentially just passed in to this function. And the height map is 2D, so that's the X and the Y. And so at a Y and an X, I have to iterate backwards, get the right orientation here. But that's how I get like what the vertices are. And you can see I'm putting it into the vertices array there. And then I have to like compute the triangles and stuff like that. The normals come in afterwards. And then I pass all that into a create mesh section. And that's what actually creates, this function creates the procedural mesh component geometry. So when I think about how that would work in 3D, I mean, it would still be the same function. I would just need, the vertices would be like, it'd be a bigger vertices array, right? There would be far more vertices, and I would have to, right now the chunks are just defined as a 2D coordinate, so I'd have to change all of that into a 3D coordinate system. And then I would also need to figure out like where I would want that to be like centered on, right? And I guess I would just have all the noise and the algorithms running on every chunk, right? Even if it's like in the sky or something, maybe. So it would instead probably be like let me look back at the map generator here. A T-ray of T-ray. I guess this would be a 3D array, right? An array of an array of an array with the Z. Well, it's difficult, right? Because I need to generate the height map first. And if I want to do a combination of 2D and 3D, I'm just that combination, I guess, is what's tripping me up on what I would have to do. I'd have to, I mean, I guess it depends on where I put the terrain chunk enter. If I put I guess would it make most sense to have the center of a terrain chunk be at 0 in the Z-axis? Or would it make more sense for that, for like, would it make more sense to have the center of a terrain chunk be like, or like the bottom of a terrain chunk is at 0? Because like I do in some of my height curves, so like here you can see this is the curve I apply to the noise to kind of give it some more interesting curvature, and the 0 is right here. So actually, values at 0 actually get changed into -0.1, and that this creates like little lakes. Like everything in here would be a little lake, and then there's some flat land here, and then a little hill, and then up here would be like a mountain, right? And so it's almost like a quadratic curve here. But I guess I'm wondering if my terrain chunk bottom is at 0, like these little lakes would have to be generated as a part of the chunk underneath it. So like the height map generation actually kind of becomes pretty complicated, because then you'd have to generate the height map and then potentially like put the values of that height map into different chunks, which would be, I'm trying to figure out how I would do that, or like what the flow for that would be. Well, what would the calculation be? I mean, I guess I would have to. I'd have to take the X and Y. Yeah. Okay, so like for each coordinate in a 3D space, you pass the X and Y to the 2D height map algo. And I would probably apply this. Well, I think I'd have to apply everything. Oh my god, if that's the case, it's going to be so slow. So I guess the root problem that I'm trying to figure out right now is when the 2D height map part of the algorithm extends beyond a chunk in Z space. Because I do have the altitude blending. So I guess that's where I'm worried. You know, I wonder if I could do something. I'm thinking like maybe I only have a single chunk in the Z-axis. This sounds scary. That sounds kind of scary. If I only have a single chunk in the Z-axis, then I can just like I don't think I would iterate over every single vert in that chunk, because that would just be a nightmare. But I would iterate over every single vert in the height map and just place it into where it's supposed to be in that chunk's verts. And I guess it would just be like a T map or something, right? Where the key of the T map would be like the index of the vert or something. But I guess, can you, if you're defining an array of verts, you don't include the ones that are like solid terrain, right? Yeah, you wouldn't. So yeah, you wouldn't iterate over either solid terrain or empty sky. Like those just wouldn't exist. I wonder, would there be multiple mesh sections? Because this is creating a mesh section at index 0. So I could have the height map be one mesh section, along with any of this 3D Perlin noise that intersects with it. And then like the cave system, well, I mean, it's all going to connect somewhere, right? So let's just go back to the video example, right? Where he has, step back a little bit. Okay, that's a good still. Go back here. So like each little floating blob here could be a different mesh section. But I guess to get this data, you do have to iterate over every vert in 3D space to like get whether or not this is empty space or not. But then like once you actually get here, like this verse wouldn't include the solid ground or empty space. Yeah, it's gonna doing the 3D stuff. That is going to absolutely tank my performance, I think. But I need to think about how this 3D stuff's going to work before I can translate everything into a shader. Before I may just end up getting too in over my head. And maybe it turns out that each, maybe I can't do the border mountains in a shader. Maybe I just don't have the skills for that. I think something like the blend, the neighbor's weighted average, could be really nice, because that's very mathy, and I think this would translate pretty easily into HLSL. I think could probably even just chat GPT that shit. But this callback function is I guess I would have to generate a map of values to pass in rather than doing the extract value. Linton neighbor noises. What am I doing here? Nice, another lambda. Oh, that's the extract. Yeah. Extract noise height. Okay. Yeah, let me look at, where's my generate noise value? Here's the Perlin information. Is there a Perlin 3D? There is. Okay. There is. Weighted moving average. Dynamic weighted moving average. Some interesting functions on here. Perlin 1D. Smooth step. Nice. Okay, so we have Perlin noise 3D, but yeah, I think I would need to... I need to hit this with a location to determine what the value is there, right? Good lord, look at this. What is this? Bunch of gibberish right here. So, that's going to be... To generate... I may just have... That's just going to need to be something that has to happen in a shader, right? Like, there's no way I can... iterate over every single... he's doing a highly voxelized version of it, and I guess I would have to come up with a... I think I'm using right now 50 Unreal units for just like my predefined vertex spacing. I kind of hate the term voxels. I hate the phrase like using voxels. Because like I get that that's how like people refer to it as, and I'm not like mad. But like, because like a voxel is essentially just like a set unit of measurement. That's all it is, right? And you're just saying like, that's how often I'm going to sample the noise, right? That's like the frequency of me sampling across the 3D grid. So it's not like a voxel is a thing, you know? And when you say voxel, I think people picture Minecraft, because that is voxelized terrain. So yeah, I think I would have to run that in a shader. I think I would have to write that part in a shader. I'm gonna let you guys watch a little bit of this, and I'm gonna be right back.
Perlin noise. That, again, is just like Perlin noise, but you plug in an X, Y, and a Z. And this is what it looks like in space. So these are just sort of the noise of 3D noise. And I can set a different threshold to say if you're above a certain threshold, you're a cloud, or whatever these are, marshmallow. If you're below a certain threshold, then you're not. But I could easily imagine that those are the shapes of the caves that I'm going to carve out of the ground, right? And that's what this would look like. Nope. This would look, nope, nope. This would look like. So now I'm like eating these clouds instead of having the sky, I'm eating them out of the ground. And I'm eating them out of the sky too, they're just not doing much, right? So if I look around, I can see there are some moderately interesting caves that are produced from this. And I'm going to just fly through the walls because this is just a demo. And I can actually find some that are pretty interesting and compelling. I apologize if I make anyone sick. Like this section goes through here. However, the 3D Perlin noise doesn't always close in on itself and doesn't connect through. It doesn't like lead anywhere. Not that caves have to lead anywhere. So Minecraft doesn't use that. Minecraft uses Perlin worms to carve its caves. Oh, there we go. This is not a bad one. So you can see, you can get some pretty good results by carving those white cloud blobs, just carving them out of the landscape instead. So Minecraft uses...
Does your internet bill keep getting higher? That's because promo pricing is full of surprises. At Google Fiber, there's no install fees, no nonsense. It's the same price every month. Visit fiber.google.com to get the same price we've offered since 2012.
What separates great thinkers and the okay thinkers isn't talent. It's what they do with their time. And the greatest thinkers humanity has ever seen spent their time fighting against death's clock. So how are you using yours? This is the idea behind the saying memento mori. It means remember, you're going to die. Not as something to fear, but as a reminder to live intentionally and to focus on what truly matters. Here's the problem. Modern distractions are stealing away our focus. We're so busy doom scrolling, procrastinating, and juggling the unimportant that we miss the bigger picture. What separates the good from the great is the ability to pursue meaningful work and to live with purpose. But how do you actually do that? Well, it's not easy, but this AI-powered tool that I've been using lately sure does make it easier. It's called Motion. Let me tell you about it. Basically, all you have to do is spend about 10 minutes brain dumping your entire to-do list at the beginning of a week. Then this tool does all of the hard work of organizing it into a manageable and actionable schedule. Not only does it organize your life, but it also schedules priorities and makes sure that you're not wasting time on trivial things. It's like having a personal coach that guides you towards living a life spent doing exactly what it is that you're interested in and what you should be doing. Because remember, we don't have forever. But with the right tool, you can make every second count. Click the button below to see how this viral tool that nobody's talking about can help you maximize your time and pursue a life of meaning before you rot back into your phone. And trust me, your future self will thank you.
Perlin worms to carve. And this is what Minecraft guy didn't have a time to code it in, but I've coded it before. It's very easy. You just do a Perlin worm in 3D. So instead of the drunken Zax or whatever you want, right? Instead of just wandering sort of on theta, like on yaw, you're also going to wander on pitch, right? So you can like wander, and then you're pitching down, and you're wandering, and then you're pitching back, and you're wandering. And maybe you're having a reaction of, well, Euler angles, yaw pitch, like that's going to produce gimbal situations. So yeah, you could do something else like pick a random angle axis, rotation, or a quaternion or matrix. But I'm here to say that it's better to just do something like yaw pitch and constrain your pitch. You'll notice in Minecraft, most of the caves tend to be flattish, and then occasionally they'll sort of dive down, and then they'll straighten out again. Because the pitch is more constrained, and it won't ever go upside down. So effectively, it's like the camera in Minecraft, where I can move the camera anywhere I want horizontally. So if I'm pretending to be a worm, I can move however I want like this. But I can only go so far down, and I can only go so far up. So I'm constrained. And that tends to produce, I call it 2.5D, really nice caves.
Yeah, I did like his method for generating caves there.
Unbelievable.
Using the
so yes, Perlin noise is awesome. Yes, I continue to pimp it, and we're going to talk lots more about it in the next talk, in our Infinite Worlds talk. Use easing functions on Perlin noise. Remember how easy it was just to take Perlin noise and like ease in, ease out, smooth start, smooth stop. How much can they change? How drunk are they? My favorite ways to organically better caves, and my recommendation is to do like Minecraft. And thank you very much.
And And this is the one I was on.
Right now, get up to $100 off
Right
a standard front and rear brake service.
Right now.
Okay.
I was like, where was I?
Depending on how I walk, I'm going to
He's
wait.
just talking about like the issues with doing infinite generation, which I don't know, is kind of like inherent a little bit. Like you just have to essentially make everything mathematical, right? I think I was probably somewhere around here when I was watching it.
Enough to affect me. If so, I have to check against each column of my chunk to see how much that column is affected by the river, because I want, as the river gets close to me, I want my heights not to just sort of carve down, that would be canyons, but I want them to sort of get softly sucked down to below sea level. So check how far the river pieces are to any part of me, this lonely chunk that's trying to generate myself, taking the river into account that originates over there that doesn't exist. And then I want to lower my terrain heights within range of the river. Right, the river I was just showing you a second ago was a range of 32, I think. Yeah. So as the river goes, it will like pull the heights of this. This would have been a mountain otherwise. Let me see if I can. Well, let me do this. Whoops. All right, so that's what the landscape would have looked like normally, and here's with the river carving it. That's the normal landscape and the river carving. So I have to like feather in the effects of the river as it comes near me. Bring them down to below sea level, again, doing Minecraft style rivers, and then feather off the effects with the distance to the river. So that means that 90% or even possibly all of the river will have no effect on me, right? Because I'm only one lowly chunk in hundreds that are sort of nearby this river. All right, so question, how far away do I have?
So I don't like the way he's like phrasing these things that suck at infinity. To me, these are all like, these are part of the you just bake these into a part of the algorithm, and then they don't become a problem, right? Like, I guess he's kind of treating it as like a separate, you know, like you generate a bunch of terrain, and then you just kind of like, and then after all the chunks are generated, then you, for each river, you know, go through the chunks and subtract out of it. But then when you generate a chunk, it's like, how do you know if the river is affecting you? Well, yeah, if you do it that way, like you would have to go through every river. Like, but no, you don't do it that way. What you do is like you sample the river algorithm for each chunk vert, along with every other algorithm that you're sampling for that vert or that voxel or whatever you want to call it, right? Like that's how you get around that.
I have to look for river sources as far as the maximum range that the river could travel, right? So if the river is allowed to wander 20 chunks away, I have to look 20 chunks away for any possible river sources, which is fine. I can do the math. I can go way far out. But that also means if I have to look 50 chunks away or 100 chunks away because I want really long rivers, now I'm going to find 75 river sources, 400 river sources. And I have to follow each and every one to its fruition to see if it
I hope he says the answer is to not do it that way.
Each one is thousands of segments.
That doesn't
against
sound like a
each of
good
my
way to do
blocks and
that.
stuff, if it gets close. I can try to do some trivial rejection. All right, so rivers must be in limited range. So using this technique, you basically just declare rivers can only go so far.
Yeah, this sounds like a terrible technique.
Yeah, we'll just say that for now. Rivers can only go so far. So maybe if this graph paper, I don't know if you can see that graph paper, is chunks, then maybe these rivers can go as far
like what
as
he's doing is saying the world gets generated, and then he randomly generates a series of points, which are these dots, and he just says walk in a direction, and that's like post effect. But if instead for each chunk he had an algorithm that was deterministic, seeded, and he asked that algorithm, you know, is there a river start in here? You know, is there a river in this chunk? Just mathematically, then it would be a lot. You wouldn't have to do any of this as to what he's saying.
Away. So if this river starts here on the blue, it's going to wander freely all day, and it can wander back and around. But as soon as it reaches out of range, then it's going to stop. And probably I don't want it to stop abruptly, though that's what my demo does at the moment. So as I'm approaching the end, I want it to sort of feather off into a delta or something like that. So a pro tip when you're doing this, if you're going to have rivers that are wandering and they're going to be constrained within a range, you're only using sort of at least half of that space, right? So one thing that I always like to do is have the river origination be but the midpoint of the river conceptually. So I'm going to go do a drunken goat, purlin wander, whatever, off until I hit the edge, and then I'm going to go back to the middle, and then I'm going to wander backwards as well.
This also begs the question for like my world, like how the hell am I going to handle water physics? Like water going up and down mountains potentially, like just water flow. I have no idea how any of that works in Unreal Engine. I haven't really touched water. I know I just literally just put a water plane with like the default water volume or whatever. That's all I've done with it. So I have no idea how to make like flowing water and to have that react to the environment or rather to the terrain. It would be really fucking cool if I could get that to work. But as far as I know, I might look up some videos on water in Minecraft, because if I remember correctly, calculating water and lava flow in Minecraft is like one of the more expensive parts of the game. I feel like I've seen that somewhere, but I'll probably look that up after this maybe.
So see here, I'm going to add the backwards parts of these rivers. So now, as long as I said, well, I'm going to start off going east, and then I'm going to do all that until I hit the edge, and then I'm going to continue it going backwards to the west, and then I can get my money's worth out of my range at least. So the river will go through that sort of midpoint. But you'll notice it doesn't, to the user, all the user sees is this blue contour, so there's no way you would assume that this is the middle point. I mean, there's more river on this side than there is on this side, and it's in no way central to the river. So it will be somewhere along the river probably, but. All right, so there are a couple of other things you can do that are cool. Oh, and I didn't show, must have missed some slides for this. So if I'm doing trees or say buildings or whatever, I would do that same thing again, but again, I'm using local noise and I'm trying to find the local minima and maxima. And once I find them, and these are actually quite large, so this would be like a space that I've set aside to put a village in. I'm just flying around so it doesn't look that big. But if I know that this thing is where the village is going to be, then again, everyone who's anywhere near that needs to know there will be a village there, and it will have these dimensions, and it will have these seeds. So what ends up happening is that every single chunk in the area fully generates the village. So chunk right here says, okay, I smell there's a village nearby, bring it on. I generate the whole village, and then I say, okay, drop that geometry into me. And nope, that cube is outside of me, that cube's outside of me, that cube is outside of me. So you can just sort of drop shapes into you. And that works with trees as well.
Yeah, he's doing...
Right, so that's how the buildings or trees work.
Get a final expert review before you file at no extra charge with TurboTax Live Assistant.
Yeah, the way he's doing it is very...
See this? Yeah, we're not into slow internet either. So our engineers do some...
for this here.
Okay, so some advanced methods.
Is it discrete
first,
construct?
You can support a few finite super long rivers. So just because you have an infinite world doesn't mean everything has to be infinite. I believe in Minecraft, for example, when you spawn, the world is infinite, but there are exactly 3 end fortresses, or whatever they're called, that are somewhere within 5 miles of your start. And if you go way off to the east, there are no more. Right? There are exactly 3 of them, something like that. So I could likewise say, oh, you know what? By the way, my river has all these, or my world has all these rivers. But I can also break the rules and say, don't be too computer sciencey about it. Be more designer. Like, no. What if I also said that there are 6 ridiculously long rivers in my world, and I'll just sort of pick points. Now, if I'm starting in a random place in an infinite world, even this doesn't work. But I can just pick points and say, oh, those, we're just going to follow the river and leave it in memory. So like anyone can check those at any time, and we all know where it is, right? So you can still break the rule. And if you have some super long ones mixed in with the medium length ones, it can help disguise the fact. Other things you can do, like we mentioned before, you could, instead of doing the flat Minecraft rivers, just pick your random source, like you would pick a building or a tree, and then follow, like do the wandering thing, except you're wandering downhill on the actual terrain, so the river flows downhill like a real river would. And it will eventually find sea level or find a little pond or something. One of my favorite tricks is opportunistic river chaining, road chaining. All right, here's how that works. I don't have this demoed.
Like so far what he's talking about, like all the features that he's adding on top of the terrain they're not baked into a part of the terrain algorithm. I guess that's what I'm trying to say. Like you need to bake these concepts into your terrain algorithm so that you don't have to find if there's a river or find if there's a village or that spawned or whatever, whatever thing he's talking about. Each vert just knows by nature of what is output from the algorithm. And I guess like for me, it would be kind of difficult because I guess water for me would be just like a completely different concept. Like as far the shape of the terrain would be fine, right? Like creating the river bed that the river is flowing through would be baked into a part of the algorithm. That makes sense to me. That's fine. But you know, in Minecraft, it's you know, everything is a voxel, so there is a water voxel, right? And so it's just literally defining this voxel is water, right? And it should flow. And I guess there's probably some, you know, processor or subsystem that like picks the flow of that, right? I guess for each water voxel, you'd have to check like, does this neighbor an empty cell? And then you'd have to be like, okay, flow into it. But for me, like, I guess water would be just like a shader, right? I wouldn't actually have. I don't think I'd be able to voxelize that for an Unreal Engine game. Well, I mean, like you could, but not for like the style of game I'm going for, I don't think. But I think the water system would have to be kind of completely separate, at least the flow of the water, right? And so that would mean that there would need to be like a water source. There are water sources in Minecraft as well. I guess I'm just correlating everything to Minecraft because that's like the easy way to think about it, right? But I suppose the problem would be like, if you have a chunk that has a river in it, I need to know that that chunk has water flowing through it. So I wouldn't necessarily have the source chunk that the water's in. But I guess all I would really need is I would have to just create like a linked list of like source to destination for the water flow. Like even if like the destination of my river or whatever is outside of the chunk, like that's fine. And maybe I even have some stagnant lakes or something like that. And then I would just say like, hey, there's no flow happening on this edge of the chunk. Like I would just have to, I'd have to calculate the next, yeah. I think I know what I would have to do. I would just have to calculate one more ring of verts. And this is a technique that I know about because I'll have to do it for normals as well. So I'll already be doing it for normals. Because if you notice, let's go back to my little algo here. If you'll note, you can actually see here the chunks. You can see the lines. And it's not because they don't perfectly match up. It's actually because the normals are not averaged. Like when you take a normal, it's the average of the verts surrounding it. And there's 3 verts. It's all triangles. So on the edge, you don't have the third one. And so because the third one is in the next chunk. And so that's why these lines are drawn here. And so to get the proper normals for these verts, I would need to generate one more. For each chunk, I would have to generate one more layer of verts outside it of the next chunks. And then use that to average the vectors to get the normal. And then that would properly stitch them together. I just haven't worried about that because that just kind of makes it, more complicated. And when you have like foliage and shit all over the ground, like it's actually not which can I render? I kind of want to see what biomes look like here. I probably need to not biome core. What do I want? I want forest PCG. Are these set to save? They are. Okay. Let me I'll turn this on. Probably take a minute. It's running. Yeah, I definitely need to cut down on the size of my ECG chunks. That'll speed up the serialization. And so, like, I can't actually walk over to the other chunks, can I? Because they don't connect. Oh, maybe I can hop up on this one over here. Let's see. What I'm trying to show is that, like, you can't really notice it. Oh, can I actually reach that? Oh, come on. Ugh, climb up. Or sprint. Damn it. Okay, so we can't... we might have to run all the way over here. And the reason these aren't connecting right now is just because this is running my, like, naive shader noise. That doesn't include jump, damn it. Well, he's supposed to, like, mantle when he comes in. I don't know if the mantling is set up properly on the terrain. Like, I think it needs the can character step up on flag, so maybe the terrain doesn't have that. But how you doing, Wormjuice? Welcome in. But yeah, the biomes aren't connecting now because I don't have... I'm just doing, like, a naive shader, like, so I don't have all the extra bells and whistles that my algorithm usually has. But I'm just trying to show that, like, you can't actually really notice that line unless you really look for it. So I'm just not worried about it right now. Here, we'll just zoom over there. Like, yeah, when you're... I guess it's a little easier in this biome. Okay, let's go to the forest biome here. So, like, there's a line right here. Like, see, when you get close, you can't even really notice it, right? So here's a line. So... when you're, like, in it, like, you can't notice the line, really. When you're down. See, it, like, virtually disappears. So that's why I'm just, like, not too worried. But when you're looking at it from, like, over here, yeah, I can see that. So when I get over here, the textures render a little bit better. I mean, you can kind of see it here, slightly. But I guess I'll have to do the same thing for water flow in some way. But yeah, I think that'll just be a completely different system. I'll have to look up what the traditional techniques are in Unreal Engine for water flow. I know it's, like, primarily shader based. And so I can kind of, like, this water volume is just, it's just a flat water body, right? But how would I actually do, like, flow? It is something different. I think probably still entirely in a shader. Maybe I'll, I know what Prismatica does some stuff with water, so maybe I'll look into that a little bit. Continue watching, though, on
For you use your neighborhood noise, and I in my code use the term neighborhood to mean the area around me that I care about, to locate local river sources, right, like I would normally. But if I know that, meaning if I am a river, if I know that you know that I know that we are near to each other, let's say were cities, for example, or river sources.
Why would he say it like that?
Then we can sort of mathematically predestined to choose to connect to each other. So, for example, I try to initiate a connection with each of my 2 closest river sources, for example. So I just do the river math. I go out, you know, in a 5-mile radius around me, or however long I have to go. I find all the river sources in the noise, the local maxima. I find the 2 that are nearest to me, me being a river source. And I say, oh, I want to try to link up with those 2 nearest river sources. So then what do? I go ask them, hey, nearest river source number 1, who are your 2 nearest river sources? Wink, wink. And if one of them is me, I'm like, cool, let's connect. Now, if none of his 2 nearest are me, meaning he's, like, in a cluster, then it's just going to sort of be me trying to, like, T-junction ram myself into his little river party. So that may not work.
Damn ads, bro.
But if I am one of your 2 closest neighbors and you're one of my 2 closest neighbors, we can connect. And I chose 2 because then you can get, like, through paths. And what's really cool, I have done this, like, in simple demos, is you can get insanely long chains of rivers that go like from source to source to source to source to source to source, connecting to each other, just happenstantially. But none of them really...
Am I being naive in that this is just kind of like a bad way to do it? Like, I don't think that you should actually be doing this. Like I was saying before, but, like, he's treating the river as, like, a post, almost like a post-processing to the terrain generation. And he's not actually baking it into the terrain generation algorithm, which is what you should do if things are going... I mean, you should do it regardless, even if things aren't going to be infinite. Like... So like, I mean, all of this is based off of noise functions that you can plug in, like, you know, either an X and Y or an X, Y, and Z, and it'll give you a value out of it. And so if you're going to create, you know, a sort of wandering algorithm to generate these rivers and stuff like that, you should make it deterministic, where given a seed in an X, Y, and Z, it returns the same value for all of those parameters. And so if you have that, you can ask this river algorithm, hey, is there a river here? You know, and it can tell you, rather than doing what he's doing, which is like querying the world chunk by chunk to determine where the river is starting or something like that. Something along those lines is what he's saying here. Like he's saying find river sources and stuff. Like, I don't think that that's how you should be doing that.
Really knows about the cousin, right? They just know about the single connection away. And then for the actual routing of those rivers, since it's, again, like from last talk, since it's an A to B situation, I need to start at my source and end at your source. I like to use splines if you want it to be really lazy like a river, or Perlin worms that sort of get a steering bias as they converge. Or if it's roads, I like to use Perlin routing. And the straighter the road, the less noisy the Perlin routing noise should be, right? Remember, Perlin routing was A star through Perlin noise. So if that noise is flat, it will be very simple straight roads.
I did like that method that he talked about, A star through Perlin noise. That was an interesting way to do it. Essentially what he's doing is he's like, he picks a source and a destination, either randomly or like an actual like destination, and he generates a like Perlin noise in between it, and he uses that as the cost for each tile in the A star algorithm, which will make the rather than just going from A to B in a straight line, if there, you know, of course, if there's no obstacles in the world, using the noise, it would kind of like, you know, make it a little curvier. So I found that to be really interesting.
Okay, so to conclude, let's come back to our problem space. So remember, understanding the problem space is key, right? It's very, very easy to get lost in the idea of what you're doing and lose track of why you're doing it. All right, do we want infinite world? Do we want massive world? Huge, large, moderate, small? Really think seriously about this. It's very easy for me as a programmer to assume that there are 4 billion seeds, right? It's very easy for me to assume that there are, whatever, this much content, because that's how much int holds, or that's what my data structure wants. To a computer, the difference between a million somethings and a billion somethings is profound, right? 20 megs, no problem. 20 gigs on disk, 20 terabytes, done, right? Profoundly different. To a player, a million worlds, a billion worlds, a trillion worlds, who cares, right? I'm gonna explore a 100th of 1% of a million worlds, or I'll explore 1,000th that many of a billion worlds. So it's cool to say on the back of the box, yeah, you have a billion worlds, but really who cares? And it changes whether you can have things in memory or not, right? It changes whether you can do algorithms or not. So don't go infinite unless you really, really need to, and don't go arbitrarily large just because it feels awesome to do so. So what's better, a billion samey planets, or a million moderately different planets, or 1,000 really interesting planets? Right? Which one is going to generate more player disappointment per hour?
I hear disappointment per hour. I love that metric.
That's my new metric. And I am guilty of this.
Way of looking at games
we had 640 billion combinations of weapons. No, there's like 15 really distinct weapons. Like, it was modular parts you could slap together, and we put that. You know, that was part of our marketing. Whatever, it's irrelevant. I love Borderlands. I played it, but you know, there were not a billion guns. And at some point, you know,
what game did you work on?
No Man's Sky, like. Although this kind of feels like that other world I had. So think about how.
Did I miss it? What game did he work on?
And at some point, you know, even No Man's Sky, like, really distinct weapons. A billion combinations of weapons? No. And I am guilty of this. Anachronox, we had 640 billion.
Anachronox. Is that what he said? Is that how you spell that? No, I don't think so. How did he say that?
And I am guilty of this. Anachronox, we had.
Anachronox. I have no idea how to see. That's a bad game name. If you say the name of the game and you still can't find it, it could be Acronox. I have no idea. Like, how do I find this? Hang on. Okay, he didn't. Right, he didn't put the entire link in there. this guy's name? Is this the guy's actual name? Oh my god, it is. Oh my god, okay, I can't fucking I hate Twitter. Goddamn. Dude, that's how you spelled that. Like, yeah, I'm sorry, but that's a bad game name. I'm sorry, but that's a bad game name. It sounds cool, but if you can't spell it, how are people supposed to find it? I had to go to your goddamn fucking your faculty page. I'll be right back. BRB. Okay, sorry, back to roasting this guy's video game name. Yeah, if I had to go to your university faculty page to figure out how to spell the name of your game, I think you should have come up with an easier to find game name. Again, it sounds cool. It sounds cool. Huh. And this is the game with like a bunch of different weapons. 2001, huh? What else did he work on? He worked on a lot of stuff. Wake 4. Interesting. Counter-Strike for Xbox. He's got a BA in physics. How do you get a Bachelor of Arts in physics? Isn't that what that means? I thought that was always a BS. Bachelor of Science. Oh well, whatever. What procedural stuff did he do though? I'm wondering. Booba. Okay.
$640 billion combinations of weapons. No, there's like 15 really distinct weapons. Like it was modular parts you could slap together, and we put that. That was part of our marketing. Whatever, it's irrelevant. I love Borderlands. I played it, but there were not a billion guns. And at some point, even No Man's Sky, like, although this kind of feels like that other world I had. So think about how important uniqueness is versus volume, and don't do it just out of hubris. All right, infinite worlds are a pain in the ass, but you can manage them. Clearly, Minecraft does. Most of the generation things that are in Minecraft,
okay.
I've done.
I want to look up.
They all have this slight extra pain in the ass to them, right? Even like your lighting propagates.
There is.
Now bring on the mayhem. One for the money and two for the show.
Fortnite bad herder. Okay. It'll make your generated worlds more juicy through the use of generation mutation metadata, allowing for each generation step to read, write, and pass notes down to subsequent generation steps, porting them to context and meaning they need the most. So, okay, maybe this is where he talks about the method that I would have used. But before that, I want to look up like Minecraft water flow. Like, I just typed in Minecraft water flow physics or something. Is this the actual technical? No, I highly doubt it.
For each block that the light passes through.
Technical. Water spreads at a rate of 1 block every 5 game ticks, or 4 blocks a second. I want to look up on, let's do like site. What's the game? I'll type in game dev. Maybe that'll give us some answers. Voxel game dev, sure. When Minecraft generates chunks, it has to consider that the chunk being created may be influenced by neighboring chunks. There may be many examples of this, but flowing water is definitely one example. So even if the chunk being created doesn't have a water source, there may be a neighboring chunk, the water source causing water to flow into the first chunk. It seems like a big problem. To create one chunk, you'd have to create neighboring chunks to check if they influence the first chunk. No, you just have to generate one more ring around the current chunk to determine what the next voxel of your edge voxels is. You don't need to generate the entire chunk. How water works in Dwarf Corp? Not found. Right. Minecraft uses a pathfinding approach to its water. This is 11 years ago. Yeah, and like these are just like random comments on Reddit, so I don't know how much stock I'm going to put into these. Where pathfinds from a source block to the lowest point it can flow. I assume that when a water source is in a chunk, I don't think that that's how it works. If that's how it works, I would be shocked. That seems incredibly inefficient. I think you kind of create a linked list of water blocks. I think that's how you would do it. And then like just for each block, if there is an empty space next to it, then flow into that space. If, you know, there's like a maximum flow, which what was it? I remember it because I built a lot of mob traps back in my day. It was like 8 tiles or something like that. It can flow up to 8 tiles from a full water tile. And then it was like a series of 4 full blocks of water created an infinite water source. Cellular automata. Hang on. Look that up. Cellular. We'll watch this guy's video real quick.
If only we had more time to innovate and move the business forward. We need help.
I really need to get to...
Welcome to a day in the life of me, Aaliyah, and my friend.
I'll mute that. Save yourselves.
Hi, today we're going to talk about cellular automata. The singular.
Is that how you say that? I've always said automata.
Cellular automaton. So we're going to look at a cellular automaton, but we're going to discuss cellular automata. Now, why? First of all, what is a cellular automaton, and why are we looking at this? Okay, so first of all, you know, you might be just arriving here from nowhere, which is totally fine, but if you had just watched the previous video, the last thing we talked about is right here behind me, a flocking system, a complex system, a system of many simple agents that when they work together exhibit this complex, intelligent behavior.
It's like so jumpy.
So, there's a lot going on in this system. There's physics, there's physics, there's motion, there's all sorts of stuff. The neighborhoods are changing as these things move about the space. One of the reasons to look at cellular automata is to say, okay, now that we achieved this complex system, let's boil that down and try to create the simplest possible complex system ever. What would that be? What is the simplest possible agent which would have the simplest possible neighbors and the simplest possible set of rules as to how it interacts with its neighbors? If we could design that system, could we still achieve complexity? So that's the question we want to answer when looking at cellular automata. Now,
I don't know.
What
is that how you say
okay,
that?
first of all, so this video is we're basically going to talk through the two classic examples, and we're going to do them in reverse chronological order, but our order is going to have some logic to it. So I'm just going to move. So we're going to go through two kind of classic cellular automata. This one is scrolling here by, this is the Wolfram Elementary CA, and this is rule 30?
Life
30?
simulations, okay.
It is, in fact, this is Rule 30, which we're going to get to. What does Rule 30 even mean? This is, we're going to talk about Wolfram in a little bit. Over here we have something called the game of life, which is perhaps the most famous, certainly the first most famous cellular automata that that sort of arrived into popular culture with a well-known article in 1970 in Scientific American. So we're going to look at these two systems, understand how they work, understand how to write the code for them, and then ask the question, great, we could just implement these and change the colors and we have some interesting patterns, but really we need to ask the question, how does this way of thinking apply to the type of work we're doing in interactive media, computer graphics, computational design, all that sort of stuff. So hopefully this video is going to kind of introduce the concepts behind these two systems, and the next couple videos will walk through the code for them, and the last video will kind of talk about other possibilities in this realm.
He says the game of life.
Okay,
is
you feel good about that? I feel good about that.
Blocks are eating other blocks.
So let's talk about, let's just say CA. Let's define a CA.
Oh.
Okay, let's define a cellular automaton. A cellular automaton is a grid of cells. We're going to look at one-dimensional grids, two-dimensional grids. A one-dimensional grid, for example, just looks like this. Here are a whole bunch of cells sitting next to each other in one dimension, which incidentally looks quite a bit like the diagram for an array. So we can see how this is going to fit nicely in terms of programming these types of things. Okay, now, if a CA is a grid of cells, each cell is defined as an entity that has a state, and we're going to look at a variety of possible states, the simplest being a 0 or a 1, right? A binary state. It's on or off, alive or dead, 0 or 1, black or white.
Automata, is it just
and
a set
each cell
of rules?
also has a neighborhood.
Is that it?
This is very important because how a cell's state changes over time is going to be determined by the sum, by analyzing its neighbor's state. So this is really the third aspect of defining a CA, which is that the state of a cell state, at any moment in time, t, is equal to a function of the neighborhood states at time t minus 1. So we have this idea of generations over time. The CA has a whole bunch of states if they're 0s or 1s, and then we say, hey, at the next moment in time, this state cell is somehow going to be calculated based on a neighborhood of states. Adding them together, averaging them, say what is the pattern, that type of thing. So this is how we define a CA. Great. So I think this actually, strangely, I'm trying different things, wraps up this video. And I guess I'll give you an exercise, which is kind of a bit of an insane one. But many of you watching this might be familiar with this already. Many of you watching this might have never heard of a CA before. If you haven't, try to design for yourself a set of rules for how cell states would change over time for a one-dimensional CA with 0s and 1s. Now, this is, of course, what we're going to look at in the next video. The next video, we're going to look at the Wolfram elementary CA, which is precisely this. A one-dimensional CA where the states are 0s and 1s, and we're going to look at what's a possible set of rules for how those states change from generation to generation, how do we implement that in code, and what results do we get. But, as a little exercise to yourself, you might try imagining this. Okay, so I'm going to pause here, and I'm just going to keep plowing through, but the next stuff will be in another video. How do you feel about that? Great. Okay, thanks.
Yili, hello. Okay, so I guess I understand that a little bit more. It kind of just seems like more so just a concept. Just ask GPT and write code. GPT, translate my entire game into a shader for me, please. Thank you. My game, Water Physics, is cellular automata based, which I guess is kind of what I was saying, where it's like you just, it's like a linked list almost. Although a linked list only has a head and a tail, or rather a next and a previous. A linked list in 2D space would be like a grid that just knows about its neighbors. It checks its... Oh, this is exactly what I was saying. In my game, Water Physics is cellular automata based. When a water voxel updates, it checks its 6 adjacent voxel neighbors. One of these voxels belongs to a chunk that is not loaded, then the water voxel simply pretends that's a wall for now and continues normally. When the chunk finally does load in, the water can flow into it as normal. Oh, okay, so he's not actually flowing into the next one. Yeah, so I think I still don't know how like water flow works in Unreal Engine, so I should probably look at that next real quick. I mean, do I even bother going down this road? This is a long route to go down to just like translate my algorithm into a shader. Like I went from like okay, I'm gonna rewrite my height map based procedural terrain algorithm into a shader real quick. And I was like, well, I should probably consider how I'm gonna do the 3D noise when I get there. Okay, now that I'm thinking about 3D noise, you know, how is water physics going to work? So we're down the unbeaten path a bit here. Yeah, I guess I'm thinking that, like, so what would happen? So my make-believe hypothetical water system, I guess there's kind of 3 states for a consideration of water in 3D space. And the state would either be like stagnant water, like water that's not flowing, flowing to or flowing from. Or I guess rather, it would be a direction, a flow rate direction, which would just be like a vector. And like I said, that would just be 0, 0, 0 if it's stagnant. So I guess maybe there's not 3 states. There's just a magnitude. Water has a magnitude at any 3D point in space. And I guess it could be like an optional vector for, like, if it's not even water to begin with. But like, let's say, like, paint time. Let's say, let's create, we're going to create some green blocks here. Okay. Create a little water. Going to be a river. So for all the verts right here, like, let's say this is not generated yet. For my chunks, I am going to need to generate all the verts that are directly outside of it to ask what is there. And I will have where the water should be. I guess it would need to be baked into my terrain algorithm as to where the water is by default. Now, I'm actually kind of thinking, like, what's going to happen when a player, like, builds something that blocks water. Ooh, that's going to be a pain. Maybe you can't. Maybe water just flows through buildings. You can also look at flood fill. Yeah, I think I'm vaguely familiar with that. I don't think. I may look at that in a second, but let me finish my train of thought here. So I'm essentially just going to have an extra series of verts outside here, and then to figure out what the edge states, you know, at the whatever my predefined voxel consideration size is. Like right now, I think it's 50 Unreal units. I'll check for each one of those, like what's right here, right? And that would determine its state. In that state, it would just be a vector. You know, a vector, right? And so, you know, if let's say water is flowing that direction, I would need to check what this, like, what's the state of this right here? Like, is it terrain? Is it water? If it's terrain, then I set the flow state here. Like, if this is all like green terrain, then the flow state here would be like probably 0 or something, because this would end up being like a stagnant body of water unless it's like flowing downwards or something. And then I guess I would need to program in like the gravity aspect of it. Like, is this going downhill? What is the flow rate of the generation source and stuff like that? Like, so let's say like this is like a water source, right? And maybe the flow rate is equivalent to the area of the water source, something like that. You know, some function of the area of the water source. So if it's just like a little tiny water source, you know, it's not going to create it'll create like a little tiny river that doesn't end up going very far. Yeah, I think this makes sense. There's probably some things I'm not considering, but I think I've considered enough here to move past this for now. I'm definitely not going to be writing this today. But I guess as a part of the terrain algorithm, there would need to be a separate pass over all the verts for the water, similar to how I'm doing it already for like neighbor blending and stuff like that. Like I have different steps here to generate a single vert, but I can do this all within a single vert, sort of. I do have to do a neighbor noise blend for all 8 neighbor chunks. And this is already getting expensive, which is why I'm going to rewrite it in a shader, hopefully, maybe someday. So I'm kind of wondering what should be my next steps. I think I still need to flesh out in my mind how my 3D noise and 2D noise are going to interact with each other, and whether or not I need to... Earlier I was thinking about whether, right now my chunks are just a follow. Nighttime Game Dev, thank you for the follow, mate. Welcome in. Right now my terrain chunks are just entirely 2D. They're defined by a 2D coordinate X and Y, just -1, 0, kind of thing. So there's no Z to my system at all right now, and I was able to do quite a good job at I like the landmass that I generated from that, so I do want to keep the 2D height map method. You can't have overhangs with height maps, though, unfortunately, and you can't have cave systems with height maps by proxy. So I need to apply some more noise. So I think I'm going to combine it with Perlin, some 3D Perlin, and like for the it's really going to be, the considerations are really going to be like how this procedural mesh gets created. I guess I need to understand how to do a set of 3D vertices. I guess it all just depends on what direction the triangles are facing, right? So I was thinking about having like an uncapped Z grid. Like a terrain chunk has like a not infinite, but like there's only one chunk in a Z axis, which sounds kind of scary. But it beats trying to think about like dispersing my 2D height map algorithm across the Z axis. Like, how the fuck would I do that? Like, that's what I'm thinking about. Because like, if I put like, I have this. I was talking about this earlier. But yeah, like here's the curve I apply to some of the noise, and you can see here at 0, it's actually -0.1, and so this creates like little lakes. Because the water is at 0, that's water level. 0 is water level. So this area right here creates like little lakes, and then there's like a little bit of flat land here, and then we get some bigger mountains and stuff. And so if I just had the chunk, like the bottom of a chunk at 0, I would need to, when I run this 2D algorithm, I would somehow need to factor that in, because this would go into a different chunk in 3D space. And that is kind of breaking my brain a little bit. Because like I would pass in an X and a Y to my 2D algorithm, and I would get out a Z. And so for each, for each voxel, I guess for each in a single Z axis, like let's just consider, like let's where did my paint go? There it is. Okay, good. Okay, clear this. So for a single Z, like let's I'm gonna draw just like here's my height map. That's my height map. So for a single, and let's say water level, we'll draw water here. Let's say water level is right here. And I'm going to draw this. So we're looking at a side profile here. And then what should I draw my chunks in? We'll draw the chunks in gray. So like let's say a chunk is, like right at water level basically. So a chunk would be like right there. Chunk would be like, oh, that's a bad chunk. Undo that. Right. And so for a single Z axis within this chunk, I guess I would have to run at every point here the 2D algorithm to get the Z from it at the X and Y to get the Z, and then I would determine, like, is this height mapped? Do I apply the height map to this? Does this have a height map value here at this point? I'm wondering if there's a way I can speed this up to where I don't have to check every single one. I think I do. I think I have to in some capacity, though. I definitely wouldn't. It wouldn't exist as a part of the vertices array. And I guess, oh man, even for the procedural terrain chunks, they can have different sections, and I guess each, like, let's say there's like a little block of we're gonna have our three, like, let's say these are like caves and shit, like little blocks of 3D noise, like these are empty pockets really. And so if I had one right here, like, would this be a mesh section right there, and then this would be a mesh, like, because they're disconnected, right? So they would be two different mesh sections. I think so. But yeah, I guess I need to look at more about how the procedural mesh works. Would it have to be? So I think, like, I'm gonna guess the way it works is that within a section it connects everything. So if I wanted disconnected pieces in the same procedural mesh, I think that would have to be a separate section. How would I know that when I'm creating this? It would be kind of difficult to parse that, I suppose. So I can kind of ask two different algorithms. I guess for anything above, like if I get the Z, if the current Z that I'm considering, well, I have a Z here too that I'm considering, but I get the Z of the height map, and I would know that that's like down here, so I know I'm in the air, and then I know that I don't need to run this algorithm. And then I would just need to check, like, how would I know which way to face the normals of this too? Or to create the triangles and the normals for this? Oh, that's going to be a pain. That is going to be an absolute pain. I guess I know that, like, so what am I doing here? What's 0 and what's 1 for me here? Like, let's say that 0 is 0, just a circle. 0 is this space, and then 1 would be nothing, or I guess it's some threshold that I set to subtract out, right? Okay, hang on, I gotta be right back again. I'm sorry, I'm getting interrupted a lot today. Apologies. Okay, I'm back. Sorry about that. Where was I? Where was I? Okay, yeah, so I was thinking about how do I know which direction, like, to render the mesh verts at, or in other words, like, the direction of the triangles. Like, it's easy for the height map because the triangles are always in the same direction. So, you know, counterclockwise based on the verts around them. Let's look at that code real quick. Yeah, right here. Yeah, so every time like a vert gets added, if we're not like at the edge, we can yeah, I guess I'm going clockwise for some reason. Oh, it's because I'm generating it backwards, that's why. I'm iterating over it backwards, rather. Because negative y is north. Yeah, so for every vert, we add the two triangles, and that's always just the same order. Easy. Easy peasy. But for, like, considering this, like, what the fuck? What do I even do? Like, I guess I would have to... I can't just consider... I guess I have to get all of the neighbor verts in 3D space and kind of query them. When I say query, I just mean like, hey, are you open space or are you solid ground? And what I was saying was that solid ground is 0. Open space would be like 1, or, you know, some threshold, right? And there's a threshold, and I just check if it's above or below that threshold to get whether it's solid ground or open space. And then I guess I kind of know at each vert if I'm solid ground or open space, and then if I'm a vert that has solid ground on one side and open space on the other, then I know that my normal is facing in that direction towards the open space side, and it would be like an accumulation of all the open spaced verts that I'm adjacent to. And so then I would just have to... God, thinking about this in 3D space is so fucking difficult. Hey, guys, stop it. My dogs are fighting for some reason. Why are you guys fighting? Hey, sit. Sit down. Good. Good girl. Good girl. Don't bully your brother. Yeah, so thinking about the direction that the triangle should iterate in. Or not to iterate in, but add the verts. What order the verts should be added in for the triangle. So we have that direction, and we have like this direction. And so if I'm thinking about this in 3D space, I think I really need to start writing that code a little bit to actually reason through it in my head, because I'm thinking like, let me get bigger. Boop, boop, boop. 3, 1, 2, 3. I'm thinking about my verts like this. And so this is just in 2D space, but it's the side profile of my landscape here. And so this is like the magnifying glass to this right here. And so the line, let's say the line is like, you know, this. I should make that, do that smaller. We'll say it's like that, right? This is the like this edge of that circle. So for this vert to decide like when this gets added, of course I'm not going to have left to right, probably, you know, I'll have to pick an order and consider that as to how I'm generating these verts. But for the generated ones, I guess I would add how many I could potentially add if this vert is an edge, is when I would add it. And I would have that threshold number. We'll just say 0.5. That's an S. 0.5 is the threshold that creates an edge. We'll just say that for now. Or maybe it's 0, because I think it goes from -1 to 1. So maybe it's 0. Whatever the number is, we'll deal with it. So if this is 0, then how many triangles would I be able to add? I'm drawing another series of these points. And this will be from the other perspective. This is like the other side perspective. And I'm thinking like these ones would be the ones that are added already. Well, really these and this one, and then we're considering this one. And so I would need to check if I'm thinking about that right. I'm looking at the side. Oh, it's so hard to think about. How many triangles would I add? Would it still just be 2? I think it would still just be 2. No, it would be 4. It's twice as much. It's 2 per. So there would be this set of triangles. There'd be those triangles. And then the ones I'm looking at it from the side in this perspective, and the ones closer to me, away from the screen, are not generated, but the ones towards the screen, behind the screen, are generated. And so I would generate, you know, that would be like, you know, back there. It's a very poor perspective of that. But I add those. Oh no, I think it would be 6. Potentially up to 6. Is that right? Yeah, because I'm thinking about like the corner, right? If this is a corner, then there would be the one, you know, back there, and then there would be one back here. And imagine those folding in. Well, no, I guess it could be up to 8. It'd be 6 in a corner and 8 if it's just a flat surface. But no, because I don't have the other verts added yet. That's why it's not 8. That's why it wouldn't be 8, because I don't have the other. It would just add, you know, when I get to that vert. Yeah. Oh, that's going to be some complicated code to get through. And then it would be, I guess I really have to nail down what direction I'm iterating in. But then I would just base it off of like whether or not there's a triangle here would be like querying how many neighbor verts would there be at the time of querying? I have to consider diagonals too. So 1, 2, 3 right here that we can see. The 3, 4, 5, 6, 7. No, 8, because this one exists as well. This vert. I wasn't considering that vert, so it's actually... And what's the total number that it will eventually be connected to? Single vert would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23, 24, 25. 25? Did I count that right? 2 times 2, 3. Is it 27? Is the answer actually 27? There would be 20 in a series of like 3 by 3 in both directions. It's 3 times 3 times 3 is the number of verts there, right? So that's 27. 3 times 9, or 3 times 3, 9. 9 times 3, 27. But then the center, if I'm looking at the center vert, be 9 on the top, 9 on the bottom. That's 18, 19, 20, 21 on one side, 22, 23, 24 on the other side, 25. There'd be 26. 26. Okay. Make sure I understand here correctly. Yeah, just subtract 1 from 27.
Dum 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 dum.
Don't know why I needed to count there. Okay. And so I would be looking at my neighbor previously generated 1, 2, 3, 4, 5, 6 points, because it would be like these, well, and this one, right? So we go from here to there to there, and then there, right? These just look like a bunch of frowny faces now. So this 1, 2, 3, 4, and then behind it would be 5, 6, 7 for the one that's behind this one. Eight, 9, 10, the ones that are in front. It really depends on what order I'm iterating in. And I guess, yeah, I need to nail that down before I can probably think about this better. So I guess in a 2D grid space, we'd be going... left to right, top to bottom. So that would be all the top one. The top row would always be generated, right? Or the row above it. Yeah, this is probably going to end up being something that I have to take a crack at off stream, because I'm just going to be blundering my way through it for the most part. And yeah, I mean, I will absolutely 100% need to run this in a shader. That is going to get expensive. I guess, like, I can do some optimizations. If I have multiple chunks in the z-axis, I can do some optimizations where I just check one layer, one z layer, for where the height map is at that, or I say one z layer. I check where the height map is at each x and y location, And if all of that is either above or below, I can just skip that algorithm completely for the next one. For all the other Z levels. So there's some optimization there. And then I probably have like a max height. That would be kind of hard to come up with, though. I guess it would be for a given noise, I would know what the max height is. So I can also just, maybe I wouldn't even need to check. Like this chunk, maybe the max height is like, you know, up there. This chunk doesn't exceed the max height, but there's no height map in it. That's when I would do that optimization. For each set of noise, I would kind of know the max height and the max depth. And I could check that just once for the chunk. And if so, skip the 2D algorithm. If I'm in the air, skip it all together. And if I'm in the ground, I only run the 3D algorithm. Which really, the 3D algorithm is the pain point, really. That's the expensive part. Okay, so it's starting to become a little clearer. What open questions do I have? I kind of understand what I would need to do to get the triangles in the right order. At a macro level, I understand. The micro level of that implementation is going to be an absolute pain, but we'll get there. I don't understand. My open questions are how the procedural mesh needs sections. Procedural mesh sections. Maybe let's look up something along those lines. Unreal Engine procedural mesh component sections. Let me put that. Where is my... Yeah, get rid of water. We're done with water. Friendship ended with water. Is there actual... No, that's an API docs. Is there anything on... No, there's nothing on procedural mesh component. How do I use sections with procedural meshes? Yeah, I need to understand more about sections. Whoops. To build 3D models. I figured one could use the section index bit to add each letter to. Even if I'm not 100% sure what the sections really are. I figured out I need to use the section index 0 for the second input mesh, but use index 1 when I'm merging that in. As the input mesh is just one section, I suppose. Okay, there's no other. I guess the specific question I need to know is for disconnected. Vertices. I think it would connect every vert in the section. And so managing those connections is going to be also pain. Maybe I should take another crack at dynamic meshes. I tried a while ago to use that for my terrain, and it was like horribly unperformant. But maybe I was doing something wrong. Reading. So you said something about triangles. What did he say to do? If you're looking at creating raw triangle data... Wait, go back. There are a few other alternate approaches which could be used to create procedural terrain in blueprint and geometry scripting using other methods. So, for example, it's possible to create a massive 1K by 1K grid object in a 3D package and import it as a static mesh. Render your procedural height map to a render target 2D, either by using materials or just loading RGB data manually. Apply it as a displacement map to the grid using the technique here. Rebuild normals automatically and then bake the result as a mesh. This sounds massively inefficient, but this mesh is fully nanite enabled and so benefits from all the dynamic particle LOD trickery.
Does this look like your internet provider? Surprise fees,
yeah, what is a
one-time
displacement
charges,
map
and
in
sudden
terms of
price hikes
geometry
hidden in the
scripting?
fine.
In this video, I'm going to show you how to create a procedural displacement mesh object using Geometry Script in Unreal Engine 5.0. So I've already created the blueprint actor and the variables we're going to need for this process. So the first thing I'm going to do is drag in the source mesh variable and get the source mesh. This is a static mesh asset variable. That's an input, public input to this procedure. So I'm going to right click, convert to validated get, and then off the isValid pin, I'm going to copy mesh from static mesh. So I'm going to wire my target mesh in there to the toDynamic mesh and the source mesh asset to the from static mesh asset. So I'm going to hook up the exec pin. Now if I compile this and I drag one of those to the level, it's going to be empty. But if I switch to modeling mode, let's make a sphere, and let's just make a torus too. We're going to use that later. So now if I go back to my displacement blueprint, I have to select in the tree over here, and I drag the sphere into the source mesh slot. You see it updates to be the source mesh. If I drag the torus in there, it becomes the torus. So that's the copy operation. So the next thing I'm going to do is I'm going to apply tessellation to this. So off the dynamic mesh, I'm going to drag a apply PN tessellation node. And that's only going to do that on success of the copy. So if the copy failed for some reason, we wouldn't tessellate. And I've got the subdivisions over here. I'm going to drag that into the tessellation variable. So now if I go back here, maybe let's use the torus again. We zoom in and we see I can increase the tessellations, and you see the torus gets rounder. Let's set that back to 0. Okay, now we're going to get the displacement map, which is the texture 2D asset. Get displacement map, right click, convert to validated get. We're going to wire that up here. If it's valid, we're going to apply displacement from texture map. That node is going to take the target mesh and the displacement map. The option struct here, we can drag off a pin to create a new option struct, but you can also right click and say split struct pin, and then you can just wire things in directly. So I'm just going to wire in the magnitude, which is the sort of height of the displacement. I'm going to compile that, and then I'm just going to put a recompute normals node off of here, because this displace node doesn't automatically recompute the normals. So if we compile that and go back, we see it still looks the same. But if I drag this stones map in there, you see it's being displaced now, and if I increase the tessellation,
is that the actual verts,
start to get
though?
more and more of the detail. You can go quite high here, actually.
Show the wireframe. Wait, go back to the wireframe. I want to see it.
And I can drag, say, a different map in there too. So now I have a procedural displacement object. And so basically I could use things like the convert tool to bake this out into a fixed static mesh when I'm happy. Oh, I dragged it in and made a material out of it. So the only thing you'll notice here is it's kind of chunky when I drag it around. That's because it's quite expensive to recompute this displacement map. It works okay if I change the settings over here, but if I actually want it in the scene, it's expensive to move around. So what we can do is we can basically disable this blueprint from recomputing when we're happy, and I'll show you how to do that. So that's what this bFrozen parameter is for. So I'm going to drag it in, get the frozen value, make a branch node off of that. Okay, and then I'm going to shortcut here. And so I'm only going to apply this whole blueprint if frozen is false, which is the default. So now we can compile and run. The only problem is when we do that, so if we check frozen, it's going to disappear. So why did that happen? Because the rebuild generated mesh event clears the mesh before it runs the blueprint. So we have to do two things to change that behavior. The first thing we have to do is select the blueprint itself, go to the dynamic mesh actor section and uncheck reset on rebuild. So what that's going to do is it's not going to clear the mesh each time the script runs. Now the problem is when we're not frozen, that means we're going to copy this mesh each time and accumulate the mesh over and over. So what we want to do is add a reset node before we do the rest of this. So I'm going to just move this over a little bit more. And the target mesh, I'm going to basically pull up and just the reset function that clears the mesh. So the false fire is up here now. And then we do that reset, like and then we pass that target into the 2 dynamic mesh here. So now if we compile this, so it's still slow, but if we freeze it,
form of it,
now it's fast and it's not being recomputed. So if we go and change these parameters, nothing will happen until we change the frozen setting. So we put this back to 0. It'll stay until we unfreeze it, and then it'll recompute. I'm only going to apply this frozen to around
where you started doing
when I'm happy. So, but if I drag this stones map in there, you see it's being displaced now. And if I increase the tessellation, we start to get more and more of the detail. You can go quite high here, actually.
Wait. Go back. Wait, slow down. Back to normal speed.
Stones map in there, you see it's being displaced now. And if I increase the tessellation.
Oh, really? It's hard for me to talk? Okay. Hard to hear. I'll turn it down.
We start to get more and more of the detail. You can go quite high here, actually.
There we go. Okay. I was saying that, like, if that displacement map method actually changes the verts of the mesh, that's insane. That's absolutely insane. And that makes me want to switch my entire algorithm to use dynamic meshes. But I don't. But if it's just like a, so I think displacement mapping is like traditionally like, you know, if you had like a cobblestone path and you put a displacement map on it, it would like kind of raise the cobblestones, but only like the render of it, right? Not the actual physical geometry collision and stuff, you know? So I don't know, like this wireframe, is this actually drawing the wireframe on the physical geometry verts? Or is it drawing the wireframe on like the rendered verts? I guess I could probably test this in some way. Apply displace from texture map. Let me actually look at that code. Apply. What was it? What was it? Oh God, I can't find it. Apply displace from texture map. Okay, I'm gonna remember that this time. GPT probably knows the answer. I don't think I can rely on that. I don't think GPT would actually know the answer. This is a very, very, very specific question. And it may not even have the training data for that. It would just guess. I don't think GPT knows the answer to that question reliably. Like maybe it would randomly pick the right answer. Okay, target mesh, edit mesh. I have looked at the dynamic meshes a little bit for like my tree chopping and stuff, so some of this is a little familiar. It's been a while. If you feed it the code, it would. I mean, I'd have to feed it the entire geometry script library, and even then, like, it would be liable to hallucinations. I would rather just read the code myself and figure it out, so I know for sure. Or, like, it would be easier for me to just copy his little blueprint in that video, and I could just check manually as well. Here we are getting the UV layer. Displace positions, though, is a vector 3D. We are getting the triangles. music on while I rock this. UV overlay. I mean, I guess we're just using the UVs to get from the texture. And what was displace field again? It's just a sample scalar field 2F. Type def. I have okay, so is it just it's kind of like a vector 2D, I suppose. Element. Edit mesh, get vert. Displace positions. Interesting. It is kind of seeming like it is. Edit mesh. Yeah, we're setting vertices. So I think that is actually changing the verts of the mesh. That's kind of fucking crazy. I think that is what it's actually doing. God damn, that's cool. So I could literally take... I could literally just take, you know, because like right now for my naive landscape here, it's just this material. I could take this material, which I've already written out into a texture 2D at runtime, a render target. I presume you'd be able to pass that into the texture node there. Can you do that? Let me check real quick. Give me a random ass blueprint here. Stop that. Blueprints. Sure. Okay, no, never mind. Dummy controller. Why not? Okay, apply displace from texture map. Give me a variable for a render target. Texture 2D. Render target 2D. I think that's what I'm talking about. Texture render target 2D. I think that's what I want. When I pass that, maybe I can't. Is this actually... It's a texture 2D object. This is a geometry script one too. Okay, so what was the other? Render target. Texture render target 2D. What about just texture render target? No. Render target 2D? God, why are there so many different kinds? Okay, so is there a way to get like a texture from a render target? If not, then I know you can like bake a render target to a texture, but you can't do it at runtime, as far as I'm concerned. As far as I know, rather. I would need it to happen at runtime. Get composite texture. Let me look in C++. At the code I was working with before. Pixel data, where's my render target? There it is. Noise render target, which is a U texture render target 2D. Texture reference. Construct texture 2D. Can I do that at runtime? It does return a texture 2D. Let me look at that code real quick. Construct texture. Okay, is there a blueprint version of that I can test real quick? That was on the texture render target 2D. What was the class? Texture render target 2D. Texture render target 2D. Okay. No, that's not a. It's not a. I mean, I guess I could have just easily checked that here. No, it's not a. Can convert to texture. Maybe I should check out what that means too. Can convert to texture. I guess just kind of checking format and size. That's good that I'm not seeing like a if is with editor code there. Construct texture. Okay, so I can at least do that in C++. That's good enough for me. I mean, I suppose I can try that real quick too, just to make sure that that works. What are my params here? Give me some params. Can you fill those out for me? Okay, so I need an outer. Add this. What else? A name. Test. Object flags. Is that defaulted? It's not. Can I pass in here? Transient? I mean, maybe just transient, I suppose. Okay. U texture 2D pointer. I guess I'll just throw a breakpoint in there. Run live coding. We'll see if that runs without any issues. I'm kind of expecting it to say that can't do that. Yep, there it is. Something along those lines. Git source MIPS. Is this just a formatting issue? May just be a format. Let's just continue and see what happens. Okay, I mean, we got there actually. There is a texture. Size 0, 0. I don't. Maybe did it actually write anything there? Is there a way I can see the data? Probably not. I wonder if that actually wrote any data to the texture or not. Yeah, I don't know. I don't know how well that worked. Yeah, this is gonna keep happening. Okay, let's get rid of that for now. What other parameters were there? Alpha override. Okay, yeah, I don't think that would have changed anything. Okay, so that's really interesting. I was thinking that I could just like literally... I could create just a plain object and then use that generated texture as a displacement map against it. And then that would give me the same result with like substantially less code. I just don't know how efficient that would be. Oh, excuse me. And that would only work for the 2D height map as well. Let me think. And then I would still need... Sample texture render target 2D at UV positions. I guess I'm trying to think, like, how would I query that algorithm when I needed information about the terrain? Delete this stuff for now. Goodbye, dummy controller. Like, I need, I would still need to, like, do more. I don't know if that's the way I should do it. I don't know if it's just because that's not the way I'm doing things, so it sounds more foreign in my head, and therefore I'm not leaning towards switching that way. Or if it's because I will need... I essentially just... I need an algorithm that I can just plug in a point to and output a value at that point. And using that displacement method, I would essentially just have to query, I guess I would just have to look at the texture in the same way that that does, which would be kind of annoying. And I would just need to make sure that those two, the dynamic, whatever the internals of the dynamic mesh, apply displace from texture, whatever the method is for that to look up in the texture, I just need to use the same. But the thing is, I also need to, that's just the 2D algorithm. I still need to where's my picture? I still need to handle situations where like one of these circles overlaps the height map. Right, because essentially what I would want to do is the new method here would be like, oh god, this would essentially turn into that would be the new terrain, the new blanket on top terrain. How much does the order of the verts matter? Because that's going to potentially be very important. Where was my create mesh section? There it is. I think the order is very important. Yeah, I should probably investigate, even if I don't use that displace mesh from texture method on the dynamic mesh. I should still take a look back into dynamic meshes and figure out why they were so unperformant. Because it wasn't even just the generation that was unperformant, it was just like running. It was like, I don't know, something maybe with rendering or something made it really inefficient. Let me try to search. Unreal Engine procedural mesh versus dynamic mesh performance. Let's read both of these. Procedural mesh performance. If you're using UE5, I'd recommend switching to dynamic mesh instead. There should be a dynamic mesh component. Apparently you can convert a dynamic mesh to a procedural mesh? I didn't know that. Didn't know that. Procedural mesh versus dynamic mesh. I've seen that people are... Like this person says, I think dynamic generated mesh and the new geometry script plugin is meant to ultimately supersede the existing procedural mesh. I've seen a lot of people make that conjecture, but I've never actually seen anything concrete about that. Dynamic mesh over small meshes. That's the vibe I get based on performance. One thing I know is that dynamic mesh has some trouble simulating physics, but procedural mesh can do that easily. Interesting. Again, all this is just like unfounded. This doesn't say anything about dynamic meshes. Mesh generation, Unreal Engine. This is 6 years ago, so I don't think that's going to include anything on dynamic mesh. This is 2016 again, I don't think anything. I make a world out of dynamic meshes. Nothing really helpful in there. Literally no answers there. Procedural mesh component rendering performance concerns. Geometry Scripting User's Guide. Didn't know there were docs on this. When I first started using Geometry Script, there were no docs for it. This diverges from the previous Unreal Engine approaches like procedural mesh component in that mesh geometry can be created and manipulated without an explicit scene representation. It actually seems like a pro, right? None of this is saying that it's superseding procedural mesh component. It's just saying similar to. Ray tracing is supported, however, nanite and lumen are not. Not a big deal for me. Key differences between static mesh and dynamic mesh. I wonder how quickly, let me like... Let me create a new world. Duplicate this. This will be dynamic mesh world test. Yep. Okay, so we're just gonna... So many mesh classes in UE, one for dynamic, another for dynamic, 3D for some static, yeah. The whole Unreal Engine ecosystem seems to be that way, not just with meshes though, you know? There's just so many things in the engine. And half of them are being deprecated, the other half are experimental, you know? Okay, we're gonna delete endless terrain. Mark the biomes as inactive, it already is. World map. We'll just delete. Well, no, we need that for the biome, so we'll just leave that there. So let's add a new actor here. I'm gonna go to blueprints. Actor. Okay. And give me an int for like num tile, like tile. It'll just be called size. This is going to be how many tiles I generate essentially. Where the fuck is my for loop? God damn. So this is going to be in Blueprint, so it's going to be a little slow to generate, but we'll see how slow it is. Okay, so this is going to be tiles, and then the test noise material. Make an instance of this. And then, okay, so for this loop-de-loop, I want to create like a dynamic mesh component. Let me pull up those docs again. I may need to just look at how I did it in C++. So I guess I'll like create a dynamic mesh component for each one. Is there just like a create dynamic mesh? Let's do that up front. So what do I got here? Request mesh. Request mesh. Is that it? What else do I have? Normal meshes, split mesh. Okay, so we're just going to request a mesh from that pool. And then, I guess I can't do that, right? I can't do that because I don't have a texture. It'd be nice to just be able to create a texture real quick in Blueprints. Only works in the editor. generate render target. I'm going to do 240 by 240. That'll be num verts. Compile num verts 240, and then let's just do size. We'll set that to like, we'll do 5 by 5. Clear color black, 16F. I want that one, I think. Maybe I needed the mint maps auto-generated to prevent that exception, or that assertion from getting triggered earlier. Raw material to render target. Material set parameter. This is what I needed an instance for this, I think. And just do create dynamic. There we go. It'll work. Create the dynamic material instance. I don't really care what it's called. Set parameter. The set vector parameter value. Yeah, that's what I want. And then what did I call it in get rid of that. What did I call it in here? Chunk location. Chunk location. We are going to set. I will need to make color. And then I will need, this is my X. R. This is my Y. Yeah. Yeah, cool. Is it X and then Y? No, it should be Y then X. This should be switched. Iterate over Y then X. Switch that. Okay, so we've set the chunk location in there, so we should be sampling the noise at the proper location, theoretically. Draw material to render target. Yeah, do that now. Okay, so now I have this like render target, and I want to apply it to this mesh somehow. Let's see, mesh. Is there something I can do here? Geometry. Nothing. Sample texture at 2D at UV positions. Okay, maybe I can do something with this. I'm just shooting from the hip here. UV list. Make a UV. Great. Okay. Nothing really I can do there. I don't know. Convert array to UV list. Convert array to UV list. I guess I would need to make an array. I would need to iterate over the verts and make an array from it. You know what? I'm going to change my size to just 1 for now, because I think this is probably going to take a while to generate. Make array list. Let me just do a UV list here. Okay, so convert UV array of vector 2Ds. We can do that. We can do that. Okay. Let's create a function for that. Chunk UV list. Verts. For loop. That twice. We are going to get your ass in there. We're going to make a vector 2D. There it is. Y, then X. And then we are going to... I need a local variable for like a vector 2D array. Vectors. Okay, get vectors, add. Okay. And then I want to return UV list. UV lost. Me right now. UV list. Okay. And then when this one completes, give me that return node. Turn, convert array to the la la la. Yep. Vectors. Okay, so now we have our list of UVs. Let's make that chunk UV list. Let's make that const pure. Okay. Now I have a color list. Okay, that will work because it should be in black and white, so I should be able to grab any one of these values. I'm doing a lot of iteration, and I don't like it. This is going to be, I think this is going to be very unperformant to generate, but maybe the rendering of it will be fine, and if that's the case, then I can probably move forward with using these, but we'll see. Okay. Chunk UV list. What are sample options? Okay. Well, I think this will work for now. What can I do with color list? Come on, geometry script. Have some super nice. Convert color list to array. It is a color list structure. Set mesh per vertex colors. Populates a scalar list with values that correspond to the 0, 1, or 2, or 3 channel of a color list. Yeah, I think that's probably what I can do. Channel, it doesn't matter what channel, because they should all be the same value. Scalar list. Oh my god, of course they're all in like a custom fucking thing here. Vertex weighted point sampling. Let's go back. I need to zoom out a little bit here. Where is my, there's my mesh. Don't actually need the mesh yet. Mesh. What can I do with you? Vertex. Is it all vertex mesh positions? What do we got there? Position list. Okay. What do I got? Convert array to vector list. All mesh vertex positions. Update vertex normal. All vertex bone weights. It mesh per vertex normals, tangents. Do I need to, can it calculate the triangles for me? Hang on, let me... I think I need a little tutorial on like the basics of geometry scripting, which this is the guy who made it. I remember seeing his, I watched the videos, these ones. UE Fortnite modeling mode. That's not what I care about. Creating 2D point arrays. Is that valuable to me?
This is a quick video.
What is the outcome? Show me the outcome.
It's compute split normals node, and now the shape is a box. So we could add more points. We've got a triangle. Now it has smooth normals around the outside. That's just the default. So we can do a split normals, compute split normals node, and compile. And there we go. Now it's sort of. This is a quick video demonstrating how to use some of the add shape nodes that take a polygon as input. So I'm going to do append simple extrude polygon. This just extrudes a 2D polygon straight upwards. So the polygon vertices here are specified by an array. So to create that, we do a make array node. This is a wildcard right now, so it doesn't have a type, but once I wire it into the polygon vertices, it's going to become an array of 2D points. So I can just add 2 more points here. We'll just do a triangle.
I don't think that's what I... Geometry script demo?
Hi, this is a quick demo of geometry scripting, a new experimental feature in Unreal Engine 5.0. The first thing to do to use geometry scripting is to go into your plugins browser, type you can use to make procedural geometry box, and pick this event on rebuild generated mesh. This is the event that runs to regenerate the mesh. I'm going to drag off the target mesh pin. I'm going to type append box. And that's going to automatically box XYZ and wired that into the box settings to allow you to resize the cylinder.
Okay, no help there. What are my append things here? Adds a set of vertices / triangles to the mesh. Blah 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 blah. Is there a, let me see here, triangles. What do I have for triangles? Do I need to actually come up with these? I think I probably do. And this is a dynamic mesh object. What do we have for... There's no calculate functions on there. Okay, generate. Build. Wasn't there like a normals function that we were supposed to be using? Normal. With normals, recompute normals. Okay, what do we have for compute? Compute vertex weighted sampling. Compute split normals, tangents. What was append? I think probably append buffers to mesh is what I should be using here, and I need to come up with the triangles myself. Append Delaunay triangulation 2D. What an interesting node. Now what I could do, instead of having to come up with all the triangles myself, No. That wouldn't work. That wouldn't work. Never mind. Okay, let's try this append buffers to mesh one. Buffers. Okay, what do I have? Literally nothing. Okay. Make? Oh, okay, here we go. Yeah, I think I probably just need triangles and vertices. The vertices is easy. Triangles is a pain. Now I have my color information here for each chunk. Now I have to like build out the verts and shit. Another function for it. Build verts and triangles. I need two outputs here. Vector array. Will be vertices. The other one will be triangles. And then this should be an array of integers, right? Isn't that what it was taking? Or no, it was some special structure, wasn't it? Yes. I guess I should just return this thing. Int vector structures. Hang on. Okay. I can do that. That's not too bad. Okay. Okay. So now I need to take in a integer for x and an integer for y. This needs to be my current chunk. I'm gonna be mad if I spend all this time doing this and it's not gonna work at all. Okay. So then we need to iterate over num_verts. You need to go aside for now. Well, I guess you will be when this one completes. That's when we'll do that. Okay, so iterate over the number of verts, and then for each one of these, I need to make vector. This will be y. This will be x. And then z should be, I will need the scalar list, right? What's scalar list? Okay. So yeah, I can just pass in that scalar list. Yeah, we'll do the scalar list. Heights. Sure. Just heights. Wait, and it's the scalar list is not an array. It's scalar list item at index, and then I need to convert this. What's the? I forget the logic for converting from 2D to 3D. Is it just y multiply by num verts plus x? Is that the index? I've done this somewhere in C++. I forget what the... I'm going backwards here. Size minus y. Wait, no, I do it here somewhere, right? In world map. I know I'm doing it here. Wait, no, I need to translate from 2D to 1D. I guess I can just increment. I can just keep track of a counter, can't I? That would probably be the easiest thing to do. Yeah, that's literally what I do here. Okay. Fuck it. Okay. Vert index counter. That goes at the end, but then we're just going to take the vert index counter, and that's going to be our index. And then I need a couple branches for the condition if x I hate that I'm doing this in blueprints. X is less than, what is it? Size minus 1. And now we need to add the vert. And the vert. This is all, whoops, that's way too far. Okay. So if x is blah 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 blah, and then y, same for y. It's getting pretty ugly. Okay. So add the vert counter. Okay. Size minus 1. Okay, if both of those are true, I could just do a Boolean and, but whatever. Then I need to add to the triangles array. And I need to add what was it? The vert index, which I shouldn't increment yet then. Let's do sequence. We make sure we increment no matter what the condition is there. Okay, so we need to add the vert index, add 1. Is that right? Or subtract 1? Well, we did add 1. Okay. Well, maybe this will be upside down. We'll see. We need to mess with that a little bit, and then vert index plus the size to get the one next. I am going, I think I actually need to, I think I need to flip these. -1, and then vert index minus size. And if x is less than the size, we're not going to do it for the first row. That's what that means. And if y, or that's the y part. If x is, yeah, and so we're not going to, we're only going to do it. Did I get that backwards? I think I might have gotten that backwards. X is less than size -1, and y is less than size -1. Yeah, I mean, I guess I got that right. We'll see. Well, there's one triangle. We go ABC and then ACD. That might be backwards. That might be backwards. A, B, E. Just do it in a different order. You get the other triangle. Okay. Triangles is... How well is this going to work? How well is this going to work? So theoretically, we've computed what we need to. Build verts and such. Chunk X and chunk Y are going to be this. Chunk X should not be. And I also didn't do anything with that. I need to be, what do I need to be doing with that? I need to be multiplying that by, yeah, I need to be multiplying that here to get the world location. And then also, I need to multiply that by the chunk X, Y, and what else? The number of verts do I need to multiply it by as well? So X, chunk X. Or do I just need to add? Hang on, I get the chunk X and Y times the size, I think. Yeah, I think that's right. It's getting so messy. But I multiply X by X? Is that right? No, I don't think that's right. I think I actually need to do... Put the X and the Y in there. I need to do that to the vector. And I need to multiply... Give me a vector 2D here. Well, just give me a vector. Actually, that'll be easier. That's going to be called chunk chord. And then I want to multiply that by size to get the world space. And I'll probably want to do a scale in here as well. And then I want to add the two vectors together to get the actual world location of this vertex. Okay. Okay, so remove those two. Boom, boom. Then heights, pass that in, chunk chord, split Whoa, that's not what I wanted. Give me make color. Okay. I mean, I guess I could just split this and use this. That's kind of more complicated than I need it to be, though. X. Well, let's just reuse this one. And Y. Okay. Oh boy. And we'll recompute normals after that. Oh boy, what is this gonna do? Am I done? What is this gonna do? Play. Uh-oh, okay. Accessed none. Okay, so the material didn't even get created? Why? Oh, the material is empty, duh. Target mesh did not have normals to recompute. Falling back to per vertex normals. Yeah, so I need to debug that a bit, I suppose. Let's look at each of these. I want to inspect some of those values. Chord 0, 0, that's fine. Scalar list, I can't even see what that is, I suppose. There are 0 verts. Okay. Why? Why are there 0 verts? Yeah, I don't even know if this works. I have no idea if the render target is getting sampled. Oh, I did first index instead of last. That would answer that question. As to why there's no verts. Oh god, it's lagging to try and render. Oh, yep, there's my 58,000 verts. Okay. Infinite loop detected. Where? Why would this branch be an infinite loop? Why would that be an infinite loop? Am I dumb? Am I dumb? Why would this be an infinite loop? Was it infinite, or did you just take... I should probably be doing a -1 somewhere on size. I mean, it's got to be this function. When this is complete, it returns the verts and tries. I mean, it was throwing it on the branch. Is the sequence the problem? Surely not. If this is false, or and it specifically has to be after that. Probably still going to be an infinite loop. Infinite loop detected. The branch call. What am I looking at here? Standard macro. Like, why the fuck am I looking at here? This is the for loop. Numverts 240. Vertex index counter is what I'm incrementing. Zero to number of verts. Wait, why is this an infinite loop? I'm sure I'm being super dumb somewhere. I just can't figure out where. Why is this for loop infinite? Okay, let's make this. Can I make this constant? Why not? Blueprint read only. The size and number of verts are blueprint read only, just to make sure I'm not editing those variables. Is it this? Is this the issue? I don't know how blueprints work, I guess. No, still. And the brand, where's the, still build verts and triangles. I guess, okay, let's just like delete shit until it, okay, so it's something to do with that last part. Why? Okay, if we don't increment Vert count. Okay. Vert index counter. Why is that creating an infinite loop? Huh? Eh? What? Wait, what? I'm so confused. What is happening in the blueprints here? This should actually be numbers. I'm done. Vert index counter. How do blueprints work? I guess I can do when this completes. When the loop... No, that's when the loop completes. Is that infinite? What is happening in the blueprints here? This is 100% not an infinite loop. There's something weird happening in the blueprints. God damn it, I knew I should have just started writing this in C++. Dadgummit. Guarantee you it is something to do. Okay, let's one second. Okay, let's go back to the calculation for this. So instead of vert index count, let's just set this. We'll reuse the variable set to, what did I say it was? It was like y multiplied by num verts, adding in x, and that is our this value. Okay, does this work? Okay, it's not I'm not showing anything. Oh, I suppose I need to add a material to it for it to actually show something. Yeah, that would probably be... That would probably be good. Material. That material IDs on all triangles. Why don't I just like put a material on a goddamn mesh? Pinned mesh with materials? I do this in C++, right? Oh, I suppose the component is what has the... Okay, hang on. So right now I just have a dynamic mesh. Okay, set dynamic mesh to this. And then I can actually set the material here, right? We just set material. And then let's change this to noise material. Give me a mesh material. Okay, so that's the actual, like, rendering representation of it. Okay, so I still don't know if I'm, like, actually computing this. Do I need to register this? I don't think so. Let's just see. I want to go. I guess I don't need to do set per vertex normals. Is it upside down? It might be upside down. Turn off the water body as well. Get rid of the water. Okay, I can't see nothing. I'm wondering, like, do I actually need to, like... What does this do? Add component. Does seem to set up attachment and register. Let's just see if I even get there. Yeah, okay, so I'm here. Yeah, I have no idea if I'm creating this dynamic mesh correctly. But like, I should see the verts and stuff. Incoming lag. Oh, there are no triangles. That explains it. Why there be no triangles? If X is less than size. Oh, there should be num verts, not size. Okay, do we have a mesh now? Oh boy. Okay, things are happening. Append buffers to mesh is actually doing things. I think I need to do a -1. And that's why I'm getting a out of bounds error here. Yeah, let's, I'm just gonna assume that's it. I'm gonna go to the bathroom real quick while that rebuilds, so BRB. Did it not build? Or no, it's just taking a while to build. Why? Okay, let's look back at this. Okay, num verts 240. What was I doing here? Size. Height map.num, which should be 240. So 240 minus 1, 239. If it's less than 239, should it be less than or equal to? I know for sure I need to do a -1 here. And that I need to iterate there for sure. And then probably also here. Oh, that's first index. Oh, that one's also wrong too. Because this is last index. So we weren't even getting the right UV list either. Okay, so that at least needs to be the case. I don't iterate over verts here. So width and height, that makes sense. This should be -1 as well. Okay, do we have triangles? It's lagging so much. Okay, I think we have triangles. I have drastically less vertices. That's not... I do have 114k triangles. I don't think that's right. I don't think that's right. Okay. Oh boy, it's gonna crash, isn't it? Yeah, okay. Same thing. Okay. Yeah, triangle, there's too many triangles, I'm quite sure. Maybe I didn't. I don't think, because I think, what am I thinking? I think it had the right number of vertices before I did the -1, which I think the blueprint node is actually kind of misrepresenting what it's doing. Because if this is saying this is the last index, I'm expecting it not to iterate over, or I am expecting it to have that value. And then numverts -1 minus size. If I'm adding 2 triangles per vert, is that the case? I mean, if that's the case, then I think I do have that many triangles. Maybe this logic's wrong here then. Let me change that back to, yeah, that's iterating properly. If that's the case, then like, how did this iterate? Does this even iterate when it's -1? It does. Can I not see what those values are? Hang on. No debug data. I guess they're both 0. So wait, does the subtract one? Does it do it or not? Can I abort? Abort. Ah, shit, it got there anyway. $58,081 is right. I know that's like the right number just based off of what I know from previous implementing this in C++. Triangles. How many triangles should I have? Maybe I should just run this real quick. Let me just run that real quick and then I can see how many triangles I'm supposed to have. It was like 114,000, I think I had. For the dynamic mesh version. Why is it? My own mustache hairs in my mouth. Okay, back to our other level. Whoops, main menu, no. How many triangles am I supposed to have here? Okay, so it is supposed to be 240. Okay, so that's wrong. But why did I have so many goddamn triangles? Oh, vertices per line. Oh, yeah, this isn't indicative, is it? The one thing I need to change is this. Maybe that's where I went wrong. Oh, wrong level. Yes. New. Okay, we still hit this I wish I could see what these values were, so I could see what... Ray index out of bounds, -1. Okay. Okay, I know what I should change next. I'm just kind of guessing. Not actually thinking about... I'm trying not to think about it too hard. Is that right? Wait. Yeah. And this may end up being upside down. Vert +1, vert plus line +1. Oh, I need 4. And then ABC, or no, ACD actually. ACD and then ABC. Oh, well, shit, hang on. ABC, A, C, D. Okay. Things are happening. This is one chunk, so it's already taking a long time. Okay, all these triangles are apparently invalid. Okay. It would create invalid non-manifold mesh topology. Okay. What are my vert counter? I just want to, let's increment through here. Can I see vert counter when I get here? Is 0. How do I continue? Alt Shift 10. Ugh. What a nasty. Oh, hang on. What a nasty keybind. F10. There we go. Oh, that's the next node. This 1 now. 2. Alt Shift 10. 3. Before it's working. Let's go to the next. Oh, we can't. Okay. Okay, so my triangles are wrong. Now. Does that mean they're just facing the wrong way? It said it would create non-manifold mesh topology. Topology. Num verts 240 times 1. Plus 0 would be 0 plus... Okay, so I think this logic is correct there. I think I translated that properly. Yeah, I wonder, can I look here? I want to see what some of the Z's are here. 0.35, so I actually do have a color there. .35, 35, yeah, maybe not, maybe the Z is incorrect. Our index counter is 10. Can't even see what the data is there, so I mean maybe I'm not even sampling that correctly. Let me look. Do I still have this code? Do I still have the code that I originally tried this out with? ECG terrain controller. ECG chunk. I do have a dynamic mesh component there. ECG component. Iterate. I did do configure material set, so maybe I should change to that as well. I mean, I can actually get something rendered in the world maybe this time. Unreal Engine wants to unfreeze for me and be so kind. Wait, I can see things. There are things. There it is. Okay. Interesting. Everything is connected incorrectly. Okay, I want to add a scale to this. And that'll come into play here. Wait, does that go in here? I think it needs to go in there. And here. Anyways, this is very slow to generate. Just because this is just one terrain chunk. I can't even switch the level very fast. Yeah, I mean, you can kind of see things. Okay, so I think the triangles are not being connected properly. Vert index counter +1. So it's like the current index. Do I still have that PCG blueprint? Oh, I have PCG terrain actor. Reanimated, how you doing, mate? Doing good today, doing good. I don't have that graph anymore. I totally forgot how I did this. It's all like super old code that I'm having to dig through. Forgot I overrode the procedural mesh component as well. I guess I had a PCG graph that like created a set of points. Let's test. Not what I want. Yeah, I think I must have deleted that graph. Shame. That's a damn shame. I don't think there's anywhere I'm doing anything special with this, yeah. Okay, so I can't see how I used to do it. For context, I'm trying to go back and figure out if dynamic meshes are better than procedural meshes, performance-wise. I did it before in the past, and I found whichever way I was doing it before was incredibly inefficient, both to generate and just render. But now I'm trying to like quickly remake that real quick in blueprints, which is probably not what I should do for a proper test. I wonder if what I should do is just like override this mesh generator. And just grab the verts and triangles from that. I'll try that real quick. Oh, I forgot. And then I'd have to change LOD mesh, wouldn't I? Because that is the procedural mesh. Yeah, that is the procedure. So I can do U dynamic mesh component. Oh boy. Oh boy. Comment that out for now. Hit dynamic mesh. Buffer. Guys, you're so loud. Get out of here. Oh my god. Girlfriend got home, so the dogs are freaking out. They're in excitement. Get dynamic mesh. Why? Where are my... Not picking up much on the mic. Okay, that's good. They're very, very loud to me. Initialize mesh. I guess the functions I was using were like... They were like statics or something. Right. Where pin buffers to mesh. This is like a statics. Yeah, okay. Geometry script library basic. What was it? Mesh basic. Okay. Yeah, let's just like add vertices to mesh. Target mesh. Oh my god, I have to create these like list things. I hate it. There's so many custom structures here. List equals array of vectors. Is this what I can do vertices with? What is vertices? It is a T array of vector, but I guess I have to, what, make shared? Okay. There we go. New positions list, new indices list. Oh, that's just an out list. Okay. Okay. I guess that's all I need. That was a different struct. Okay. Apparently that's what I need to do for vertices. Alright, I will try focusing on some coding. I lost all dev skills in low-level languages. I'll keep your stream on in the background and try and focus. Yeah, for sure. I'm happy to be the best background noise possible. Okay, add triangles to mesh. Yeah, now I gotta create new triangles list. There we go. What are you mad at? T-array of ints. What are you expecting? F int vector. Okay, so that's a little bit annoying. That's going to be a... God, look how many... How much red there is. Just make a new list, rather. New triangles list. And then an add triangle. I can't add to this fucking thing? Okay, so I need then T array F int vector. Okay. New triangles list. I'll say triangles int array. I don't think I do it the same way as the procedural mesh component. I think that's all I need to do there. Okay. God, I hate how it's all in statics. It makes it really in these static functions here. It makes it very hard to find out what functions I have available. I have to figure out which one, and it's across several different ones, so I have to like guess. Normals functions. That per vertex normal. Okay. Okay, I'm curious if this just ends up working. What are the odds this works the first time? Very, very, very low. Very low. I don't even know if this will compile properly the first time. Probably not. Terrain chunk. Yeah, I knew it. Oh boy, okay. Copy all of it. I probably should just only do this. This will just be mesh generator. Okay. Is that the only thing that failed? Okay, we're gonna just comment that out. That doesn't even work anymore anyways. Don't care about that either. Okay. This will be a much better test of like how performant it is. I should turn down the render distance though, like a lot. 128,000, let's just do 12,000. Okay, something rendered? Oh my god. Is that the dynamic mesh? It's the material looks so weird on my screen. Does it look like that on stream? Hang on.
Welcome everyone to unrestricted
Stop that. Stop that. It is. It's like weirdly pixelated. Like it, I don't know. It's probably kind of hard to see for you guys. Do you guys see this? That worked the first time. That's crazy. That's fucking crazy. Okay. Now, did I actually get? There's my character. You're probably record scratch. You're probably wondering how I ended up here. But it's got this very weird material effect on it. Okay, it is actually rendering something. Okay. Let's do the full thing. That was a lot faster. And I don't think the collision is proper. I don't think the collision is correct. I think I need to compute that. That may be where the well, hang on. Let me do the full before that happens. Do this. It's doing stuff. Pause so my guy doesn't fly around. Hey, dude, it worked. It fucking worked. It's so interesting. Like it's drawing the materials on here very strangely. Like this is an effect that's not happening. And it's like a screen space effect. Like you can see it real bad over here. A very interesting effect that's happening. I have absolutely zero idea why that would be. Maybe normals or something? Huh. Wow. Wow. Okay, so that worked quite fast. Now, geometry script library collision functions. Okay, what functions do I have here? Generate collision from mesh. And then what? And then what? And then what do I do with the collision from that? Set dynamic mesh collision from mesh. So can I just do this? Get dynamic mesh to dynamic mesh, and then I need some options here. What am I looking at? I guess we'll just leave that as default. Okay, let's generate some collision. I don't know if I'm just like spawning on it or what. How can I tell? Where's my character? Bring me the character. Oh. That's not me. Wait, where is he? Okay, I mean, maybe it is. Am I gonna actually hit this or not? No, we're just gonna go straight through. How was I doing collision before? Oh, I am initializing here. I don't think that calculated it correctly. Set simple collision of dynamic mesh. Maybe this is what I need. I need to, okay, and then this can be like the set of, I guess I just need some component. Generate collision from mesh. That sounds more so like what I want. And what's the return type here? Whatever, auto, simple. I'll just put collision. Does it return simple collision? It returns F geometry script simple collision. It do. God, everything is its own struct, isn't it? Okay, let's see if that works. Oh, I also probably need to do this in the other location as well. Where's this called from? Is this even called? No, it's not. Okay, so everything I'm doing here just like isn't even ever called. Okay. All right. Well. Okay, I should have been doing it here. Okay, well, that would maybe explain why the other one wasn't working, but we'll see if this works. Okay. Show me collision. Oh no. Okay. That's simple collision of dynamic mesh component. Okay, what was the exception? Querying is not safe. You should blah blah blah. Okay, sure. Yep. No, thank you. Okay, so that needs to be done on the game thread, I suppose. RIP. Okay. Okay. Well, here's a game thread. Do it right afterwards. Okay, let's try that then. I'm just like absolutely shoehorning all of this in. I just need to see if it works. And it actually works surprisingly well, so maybe dynamic mesh components are the way. Although the weird material artifact is quite strange. Quite strange. Play. Okay. Okay, I don't think that that's built. Collision. Okay, collision. No collision. Okay. I thought that wallpaper was your new terrain for a hot second. Oh, shut your mouth. My ass is cavernous, but it can't fit that much smoke up it. So, these are dynamic meshes now, but it's got this really weird material artifact on it. It's probably kind of hard to tell. I think you can see it more in the background here. It's so strange. Like, I've changed from procedural mesh components to dynamic mesh components, and the material looks rather weird. And I'm also struggling to get collision working properly, so... isn't there like a collision one? Look at those verts. Visibility collision. Okay, cool. Layer collision. Okay, cool. None of that helps me. Lit wireframe. Oh. Oh. Okay, I thought there was a better collision, like, viewer. Okay, but regardless, yeah, I don't think it's building the collision properly. Let me see, is this actually getting hit with, like, stuff? Okay, we are getting here. So let's step through. Box, okay, so I don't think just a simple box element is what I'm going for here. Although maybe it is. I'll have to check how I do this for the dynamic mesh tree actor. What's the main difference between a procedural mesh and a dynamic mesh? So procedural mesh components have been in the engine for a while. And it's just kind of like a way to provide vertices, triangles, normals, this information, and it builds a mesh out of it. Dynamic meshes are like a new thing in the geometry script library, which is super cool. They have a lot more functionality to them. And you can, like, That's what I do for the trees. In my level, when I chop them down, I convert the static mesh into a dynamic mesh, and then it's got a really cool function for, it's called a Boolean subtraction. So you can like literally just copy it from a static mesh. They have a ton more functionality to them. They're like a new thing though. And I'm trying to see if they're going to be, because I tried to do this a while ago, and they've probably gotten better since then, but I've tried to change my procedural mesh components into a dynamic mesh component because it has more functionality. And it was like really I was like, okay, that's, you know, that's the drawback. And I haven't given it another thought until now. I'm like, let's see if they've gotten better, or let's see if I was doing something wrong. And they computed actually quite nicely, to be honest with you. Yeah, sort of. I mean, it honestly at this point it just kind of seems like procedural mesh component is just like an old. A lot of people I've seen on the interwebs have been alluding to the fact that procedural mesh components are on their way out and they're being superseded by dynamic mesh components. I thought one was for more. Like the geometry script is, a lot of it is like it's used in Lyra a lot to like build the, it's for like mesh modeling, really. But it can also be used at runtime. So a lot of the functions in it are for like mesh modeling and stuff like that. And like I just watched one video.
In this video, I'm going to show you how to create a procedural displacement mesh object using geometry script in Unreal Engine 5.0. So I've already created the blueprint actor and the variables we're going to need for this process. So the first wire might going to be empty. So the next,
let's skip forward a bit.
I'm just going to wire in the magnitude.
Okay, check this out.
Set that back to 0. Apply, and I have to select it in the tree over here, and I drag the sphere into the source mesh slot. You see it updates to be the source mesh. If I drag the torus in there,
editor modeling tools use it. I think so. So
that's the copy operation. So the next thing I'm going to do is I'm going to apply tessellation to this. So off the dynamic mesh, I'm going to drag a apply PN tessellation node. And that's only going to do that on success of the copy. So if the copy failed for some reason, we wouldn't tessellate. And I've got the subdivisions over here. I'm going to drag that into the tessellation variable. So now if I go back here, maybe let's use the torus again. We zoom in and we see, I can increase the tessellations and you see the torus gets rounder.
So he's like simplifying the mesh.
Okay, now we're going to get the displacement map, which is the texture 2D asset. Get displacement map, right click, convert to validated get. We're going to wire that up here.
So he just copied one of the in editor like primitive meshes, a torus. He simplified the verts on it with tessellation.
If it's valid, we're going to apply displacement from texture map. That node is going to take the target mesh and the displacement map. The option struct here, we can drag off a pin to create a new option struct, but you can also right click and say split struct pin, and then you can just wire things in directly. So I'm just going to wire in the magnitude, which is the sort of height of the displacement. I'm going to compile that, and then I'm just going to put a recompute normals node off of here because this displace node doesn't automatically recompute the normals. So if we compile that and go back, we see it still looks the same. But if I drag this stones map in there, you see it's being displaced now. And if I increase the tessellation,
like, isn't that crazy?
Start to get more and more of the
like
detail.
He just gave it a noise texture and it edited the mesh, like the actual mesh vertices, not like displacement maps really just change the rendering, like the visuals of it. But like this is actually changing the mesh.
You can go quite high here actually. And I can drag, say, a different map in there too. So now I have a procedural displacement object. And so basically I could use things like the convert tool to bake.
And then they all have the dynamic mesh. You can like bake it to a static mesh too. So that's like, I assume that's what the modeling tools does. He has the modeling tools
this
over
out
here.
Into a fixed static mesh when I'm happy. Oh, I dragged it in and made a material out of it. So the only thing you'll notice here is it's kind of chunky when I drag it around.
So yeah, I watched that and I was like, damn, that's fucking crazy. I didn't know it could do that. If I could just write my my noise into a texture, which I already have it in a render target, I could just apply that, you know, directly to the mesh. the dynamic mesh, and it's like it just takes like so much of my mesh generation code. Just throw that out the window because it all happens in a few nodes. So I saw that and I'm like, okay, I should probably try to see if dynamic meshes are the answer. So yeah. Now I gotta figure out how I did collision. It's got like collision nodes. Okay, set simple collision shapes. Okay. So yeah, these are dynamic meshes now, and it's generating quite fast, so I'll definitely need to do some comparisons with some actual hard numbers. Let me copy what I was doing here. So I had this, and maybe I do or don't need to do this on the game thread. We'll just do it on the game thread just in case. Comment that out for now. And then I have this. Oh, I like created it manually, didn't I? Okay. Collision mesh. I suppose that's just the stock mesh. It's dynamic mesh. Get mesh pointer. Do I need that? I suppose I do need that. Okay, we'll try that. That's probably going to be quite unperformant. But let's see if that actually gives me the collision that I'm looking for. And I can probably, honestly, compute that off the game thread. Yeah, compute that off the game thread. What am I thinking? What am I thinking? Yeah, and then pass in a ref to that. Don't copy it, that'll be expensive. Okay, yeah, do that. Collision incoming. Fingers crossed. Vertices hides class member, okay. T-ray vertices. I mean, I should already have the vertices. Yeah, okay, so we don't need to do that. Indices, however. Yeah, for the triangles, yeah. Or do I have that here? Okay, let's just comment that out for now. If triangles works. Okay, here we go. Collision, please. Please. No. No. Okay. Give me back that code that I commented on. And it should be, I should be setting the collision profile name, object type, mobility, blah, 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 blah. Do I have use complex as simple collision? Do I need that set? No, I would want that to be false. I would want that to be false. Where am I? Am I actually ever setting the collision on here? Let me look in rain chunk. Okay. Maybe I need to explicitly turn collision on? I don't know. I didn't have that before, so curious as to why that is necessary now. Although, did I try it with the new thing? Let me just try that first. Gods. I'm trying to like actually make sure that the collision, okay, just goes straight through. Okay. What are your actual collision settings here? What is this? Okay, some editor nonsense happening here. Great, great. Okay, what should I let me do here? Select collision enabled, query, and physics. It is. Okay, maybe I need to explicitly do that. If this doesn't work, then what? I don't even know. I don't even know. It's very similar to what I'm doing for the trunk. Maybe I'll just copy everything from that class if this doesn't work. Aha! Collision is collisioning. Aha. Ooh, okay. Okay. Yeah. Chip it. What happened to that chunk? Like, the other ones aren't correct. But what happened to that one? What fucking happened to that one? Okay, let me see here. Copy all this again. We're gonna just copy and paste. Paste. Pipe, yeah. Okay, vertices. Change that to like verts. Just to verts, rock mesh, get dynamic mesh. Okay, now let's try this. Exact same. It did work quite fast as well. Actor can't step up on. That complex is simple collision. I didn't see anything else that might be relevant there, so we're just gonna go with this. It is progress, yeah. Okay, sick. That's... Well, I'm not even standing on top of the collision wireframe, which is weird. That one chunk is fixed, though. Why is that one correct? What? Of course, the one I randomly click on has correct collision. The ones on the very edges? Okay, that one does not. So it starts correct and then drifts. So I don't... The chunks should start... I mean, they all generate in parallel, but it should start with 0, 0, which is the one my character is on. So I don't know, like... I don't know, for some reason the ones in the very corner, like that one's correct. This one is like... kind of looks correct, but it's like... higher than it needs to be? I don't know. Yeah, so far I've seen 2 that are actually correct. What a weird series of events here. I don't know what the answer is here. I'll look at the collision settings. I'll not raise this anymore. Okay, there we go. Collision settings. It says use simple collision as complex. Enable complex collision. Simple and complex. I don't know if that's going to change anything. Oh, here we go. Use complex collision as simple. That looks right. Okay. I'm going to set those parameters on here. Use what is it? Collision type. Use complex as simple. Yeah, okay. Okay. Complex collision is just the mesh itself. Simple is some generated nonsense from the editor. Well, I mean, I guess that's fine in my case then. Maybe I don't need to explicitly generate, because like I do want the mesh itself, because like it's not like I can simplify the verts anymore, you know? Like that is what I want, so if that's just built in, then so be it. So be it. Okay, but do you see this like material? Like it's probably kind of hard to tell on screen, but do you see how weird the material, it's like screen space pixelated sort of? It looks like, it looks kind of like a CRT monitor. It's probably really hard to see on stream, though. It's weird, because, like, the grains are, like, they're not, like, world-spaced grains. They're, like, the grain stays in the same spot on the screen. regardless of how I move, but it's only showing up on that material. What is this? Yeah, so I guess I don't need that if I'm just gonna... Yeah, we don't... I guess we'll just get rid of that. Why not, right? Through an error anyway, so... But it is weird. I don't know. It's something to do with, I guess, how the material is applied. I wonder what other material functions I have. Yeah, I'm just calling set material. Do I need, let me maybe, I know there's like a configure material thing. I don't know if set material or configure material, like what's the difference here? I mean, it just does set material internally, so that doesn't really help me at all. View geometry script library. There's got to be some material functions in here, right? Mesh voxel functions? Hang on. Okay, there's only two functions in there. That excited me for a second there. Mesh material functions. What do I have? Another interesting thing that you can do is you can actually split the mesh by materials, like, because you can of course map materials to UVs, and the dynamic mesh would know which like vertices that is, and so you can actually split it into multiple meshes based on what the materials are. And that's what I do for the trees. Like, I know that there are branches that have one material on it and then the trunk is a different material, so I just delete the branches off of it, all the leaves, when I chop it down. And of course I'll play some particle effects for like leaves falling and stuff eventually. Yeah, I wonder what it is about the dynamic mesh that's causing that weird material effect. And this is my, like, this is like a naive, oh no. Oh no. Do I still have the collision and it just didn't work? No, that didn't, so I do have to do that collision stuff. Okay, I do have to set collision on it then. Interesting. Why does that work? And why isn't there an easier function for what I'm doing here? Let me look back at those collision functions. Generate simple collision shapes. They're just like a generate. Generate simple collision shapes for an input dynamic mesh shape. Maybe I should see what that looks like. Most of these are just generated body, okay. Okay, maybe I can just throw this simple collision on there. What was the option struct I needed? Yeah, that one. Give me that. Already have one of those? No. Okay, we're good. So, generate collision from mesh. Okay, so let's try collision functions. Geometry script, simple collision set, simple collision of dynamic mesh component. Yeah, okay. Okay, what are my params? Collision. Oh, I can just pass in. I'm dumb. Yeah, just pass in the initializer. Okay. So let's see if that works with my like complex collision settings or whatever. We'll play around with that a bit. Play. Fatal error. Why is that fatal? Out of like, why would this be out of memory? Why would this have caused an out-of-memory error? I mean, I guess the way I was doing it before was fine, I suppose. I just need to make sure to use the complex collision for everything. Fine with me, I suppose. Okay, let's try again. What this was working great. This was working great just a second ago. What happened to you? What happened? You all saw it. It was working. It was working. Oh my god. What is all this data? Your islands. Oh, everything's invalid. Why? What's I wonder, can I set this on the background thread? Update collision. I'm gonna assume if it's rebuilding physics data, I can't do it on the back. Okay, fine. Let's make a copy. See if that works more consistently. So this is an interesting development. What does this mean for me for the future of my procedural terrain? If I can get that material thing figured out as well, so why the materials look so weird, then this is a high consideration to move forward. Now, there's a lot I don't understand about these dynamic mesh elements or components, and they have a lot of functions. So I think it's going to take a lot of research to actually get to where I'm comfortable using them, but it'll be really nice for things like digging and stuff. The collision do be there now. You know what? Let's try something. Let's run PCG and see what happens. Well, I wanted to play around with the collision settings. Project default, simple and complex. Okay, is this correct? Is it all correct now? Hang on. Now give me one like in the middle. Give me 0, 0. Where the hell is 0, 0? All the way at the beginning. Okay, there's 0, 0. Simple as complex. Simple and complex. Wait, is it right now? I didn't change anything and it works. Okay. Oh, no, my character fell. Okay. Well, I guess I turned off the collision on accident. That's why he fell through. Okay, hang on. What was that? Collision type. Use simple as use complex. No. Use simple as complex. Does this work? Reload. Yeah, I do feel collision there. Okay, that worked. Why didn't that work before? I swear I had this combo before. Okay, I mean, that's fine. We have simple collision now, which is it should be the exact same anyway, so not a huge Not a huge deal there. ECG, let's turn you on and see what happens. Activate. That works too. We're loading some old data. It's a bit laggy. A bit laggy. Oh my goodness. Then we have some garbage collection issue happening here. Okay. I guess just what I wanted to check there is that the PCG was actually spawning on the terrain all right. Okay. What are next steps for me here? So I started the stream today kind of asking the question of like, how do I translate my algorithm into a shader? Right now I'm kind of using like a shitty version. I don't have all the bells and whistles in my regular algorithm, like the altitude blending and the noise blending and the zone borders, and that's why all the different biomes didn't match up, and there were the floating chunks and whatnot. Because I was just testing to see how fast a shader would render, and it renders quite fast. Let's see, maybe. Let's see. Use the old method. Okay, let's see how long this takes. We immediately crashed. Why? Wait, why is it broken now? We're all empty. What? Oh. Yeah, I did the wrong thing. That was the wrong place to do that. Okay, rebuild. Oopsies. Okay, so now we're doing the old thing. So this will be all on the CPU. And I guess what I'm trying to get out of this is like, how slow is the dynamic mesh at generating? Maybe it's faster. Because I know like the old terrain used to generate in around, it was anywhere from like 45 seconds to a minute. That's how long it would take to generate the set chunks. I'm going to see how much different that is. If it's faster, booyah, baby. You know, we're going to definitely move forward with dynamic mesh components and make them work. Slower, we want to see by how much. Well, yeah, it takes quite a bit longer. Make sure I'm still doing things. Okay, we're still pumping through. Okay, now the collision's messed up. What? Wait, that was just working. What happened? Okay, 54 seconds. So I think that's maybe slightly slower, but only ever so slightly. So I think that's fine. Why is the collision that way? What am I standing on? Am I taking crazy pills right now? Why? Why? Why are you like this? Terrain chunks 0, 0. Enable complex collision. Use complex collision as simple. What is simple and complex? That does nothing, but we'll use complex as simple. Okay, so now, why did that work once? And if I run onto a different chunk, I just hit a wall. How can I view the simple collision? Because this is not showing me, like, the proper collision. Collision analyzer? Okay, no. I just want something to properly visualize the collision. Yeah, I don't know if there's a way, because this is, I guess we're only visualizing a certain collision. I'm definitely just hitting an absolute wall right here. Huh, okay. So I guess I do need the, where is it? Yeah, I guess I do need the enable complex collision, collision type, use complex as simple. I don't know, you all saw it, like it worked once. It did work one time. I ran live coding. I swear. I swear. Okay. I guess we'll get another sample for like how long this takes now as well. I wonder if the UVs are weird and that's what's causing the graininess. Because I was calculating the UVs for the procedural mesh. And I'm not doing that for this mesh, so maybe there's something UV related I need to do here. Uh-oh, there's a missing chunk. How did that happen? There's a couple, actually. How did you guys get forgotten? Uh-oh. Pinned buffers to mesh. I think maybe I should just use this one. I'll have to make this buffers material. Yeah, give me that stuff. Give me that stuff. Okay. Dynamic mesh buffers triangle list. Oh, that's why. Okay. Did you finally finish generating? That might not be representative because I was tabbed out. Oh, that one doesn't have collision. Weird. Oh, there it did. Okay, just okay, the debug show thing didn't oh, it's false alarm. Okay, so that's fine. That's all well and good. So that's the old method. Go back to the naive shader just so we can get it generated a little faster and iterate a little faster. Pin buffers to mesh. Okay, so now I have to set these like buffer values. Vertices equals blah blah blah. So comment that out. Although the indices list, do I need that? Maybe not. Buffers.triangles equals triangles int array buffers.uv. I guess just UV 0? Let's see what happens here. How much faster that was, 5 seconds. Okay, it looks better now. That was the issue. I wasn't supplying UVs. Okay, sweet. I'm learning how things work. That's crazy. Who let me do that? Who let me learn things? That's wild. The human capabilities are kind of wild. Like, I don't remember what the hell I ate yesterday, but like I can remember what the hell UVs are for. Sick. Okay, now the material looks a lot fucking better. I guess it was tiling it a lot at a very, very tiny interval. Okay, we're off to the races with dynamic mesh elements now. I don't know what was I doing that made me write them off so hard before. Maybe they just weren't as good back then. I was trying to do it through PCG. So let me run that again. I want to get a draw frame. I want to do a stat unit. Okay, the draw is 3.4. Okay. Yeah, I'm wondering if the rendering performance is better or worse, you know. For now it's good. Yeah, okay. We're off to the fucking races here. So now I gotta clean up everything. Procedural mesh related. And before I was asking the question, when I was going over my This is my beautiful drawing of how to do 3D noise and how to combine it with my 2D height map terrain. And I was questioning how the mesh sections work in the procedural mesh component, but now I guess I just need to question how the dynamic mesh components work. So, different question. And what we're looking at here is like this. Let me draw this green. This, tracing this all in green. This is my terrain. And this is my terrain on drugs. Blue is water level. And these white ones, which maybe I'll change to gray, these are like the pockets of 3D noise. These are the pockets of 3D noise. And I'll show you what I mean by that. Like this. We're looking underneath the terrain. So here's, if you render the 3D noise even in the sky, this is what we're talking about. Right, that's 3D noise, but it's rendered in the sky. Obviously, you get rid of that. That's 3D Perlin noise. He's gonna get rid of it here. There you go. And so this is it intersected with the ground. And it creates these little pockets. And then if you go underground, show the underground view. Creates these little globular pockets, right? It's not a cave system, really, but it creates little pockets. So I'm going to combine that with Perlin worms to create a cave system. Because a Perlin worm just kind of like, you know, goes around in 3D space and creates like a little cave system. And you can make them like split off from each other and stuff and circle back around. And I'm going to combine that with these pockets. Perlin worms, yes. But I'm going to start with just these pockets because I think that'll be simpler. And so when I'm talking about these little pockets, this is like a side shot of the terrain. And so I was trying to think of Nightmare. Yeah, well, we'll get there. I was trying to think like how I would calculate, because I would think that I would need these to be like separate meshes. Like this is a mesh, this is a mesh, you know, this, you know, is one big mesh chunk. But then you could have a pocket right here that intersects with the ground, with the height map terrain. And so you'd need to actually, what it would be, you know, it would look like that originally. But you wouldn't want to do that. You'd want to actually delete those because that's where it connects. So that's going to be an interesting consideration. And then it's going to be concave. So that's going to be even more complicated. Ooh, and this says convex LMs. Ooh. Ooh, ooh, ooh. Wait, do I have that right? Wait, so can I not have convex collision? Wait, which one is which? Yeah, okay, yeah. Concave, I would need concave collision. How do I do that? Okay. Okay. Directory. Let me find this directory. Geometry scripting. Copy path. Sure, absolute path. Directory. In geometry scripting, show me concave. Shit. I mean, there's got to be a way, right? There's got to be a way to do it. Concave collision. Oh great, the link doesn't work. Fantastic. Create multiple collision boxes to create the shape you need. Okay. That's... I guess I never understood that that was how collision's done in game engines. Okay. To make the hole in the second picture, you just need 4 meshes to divide it up so it's not one single. You see it. What, okay, there's no example there. Dynamic mesh collision. Yeah, I ended up clicking the same shit, so I arove to the same conclusion these people did. But I guess, does that mean I'll need to break up the collision? Like if I'm creating like a tube and I want collision to be on the inside of the tube, how would I do that? Not that I would know how to do that with a procedural mesh either. Yeah, that's going to get pretty complicated. Although, if I have just like a completely enclosed space, back to the diagram. Back to the diagram. If I have a completely enclosed space, like, that's never going to be rendered until someone like digs into it, right? Which would connect it like this. So basically there's only convex collision and you compute concave by making convex meshes in the shape you need. That's what I saw with my very limited Google search. I didn't know that that's how like collision in engines worked, but I guess that's how it goes. I don't know how I would like compute that, you know? Like if I'm iterating over the verts, where do I begin and end? That's so complicated. Looked into 2D collision and convex is really simple, concave is not. Yeah. Yeah, that's what it feels like. So I know like the... let me look up another video of Ryan Schmitz, who is the creator of Geometry Script.
Because it's quite expensive to...
Another video that I've watched. Where's the Boolean subtraction video? Wait, hang on. Is this the right one? Yeah, I think so. Okay.
Upgrade to Google Fiber.
Ads.
Hi, in this video I'm going to show you how to use mesh booleans in Geometry Script, an experimental feature in Unreal Engine 5.0. So I've already made my blueprint actor, and I've already done a little bit of setup in here, and I'll just show you how to wire it together. So I've got my... I've set up a radius parameter, so I'll just set that up here on the sphere. Wire that in. So now if I go over here and drag the radius slider, you can see...
So that's... I bet he's not...
It's updating that boolean as I change the settings. So I'm just going to do one more thing.
He's not doing the collision, is he?
I'm going to sort of tile that sphere. So I'm going to allocate another compute. I'm going to drag the tile that compile. Okay. Well, then white degree trans pen mesh. There's also
was another video
repeated pen
I was
mesh.
thinking of. Here we go. Here we go.
Hi, in this video I'm going to demonstrate something that a lot of people have been asking about, which is how to use Geometry Script to generate or change meshes in-game or at runtime. So I'll show you the output of this video. This is a cook build, just a little demo. So basically I've got a character here and a wall, but then parts of the wall are going to start disappearing because I'm Boolean subtracting boxes out of them on the fly, and then that's going to create a hole in the wall that I can run through.
Like look at that collision works perfectly, and that's just calculated, I'm pretty sure, by the library. So if the library can do that, then I think I'm probably good.
So that's what we're going to make. Let's get started. Okay, so the first thing we're going to do is get our dynamic mesh to do anything, right, as we drag this box around.
What you can do with this is you can do like bullet holes too. Like if I create everything out of a dynamic, I can transform any static mesh into a dynamic mesh at runtime, subtract some verts out of it, and then bake it back into a static mesh all at runtime. So you could take that to its logical conclusion in a game of like, you know, your player is casting a fireball, shoots the fireball at the wall of a building that the player made, and then it you know, dents the building or something, or like explodes some chunks off of it.
So what we could do to test it is go back to the construction script and just call that function once. So we see now there's a box, and if we drag the seed around, that first box is...
And what he's doing, the Boolean subtraction is just like you have a mesh and you subtract it from another mesh. And the library just understands how to do that. It just understands how to take a mesh, subtract it, or add it to the other mesh, and it changes all of its verts.
And I go to a random point. Back to 37. Okay, so now all we need to do is make that happen. So, we'll delete this. Is make that happen, you know, as time progresses. That's what happened in the video. So we're going to just get that. I guess we could also, there's one thing you'll notice is that we can just run directly through this wall. So it doesn't really matter if the hole is there or not. That's not what we want. Oh, I know what I missed. I want the box height to be up a little bit in Z. Okay, so what do we need to do is we need to select this dynamic mesh component. We need to turn on collision because it didn't have collision turned on by default, because generating collision is a complicated topic. But what we're going to do for this one, because it's this complex shape, we can't easily generate simple collision shapes. What we can do is turn on complex collision, which is basically mesh collision. It'll collide with the mesh. So we'll check this enable complex collision box, and we'll change the collision type to use complex collision as simple. So then we recompile that. So now when we run, you'll see that I can't run through the wall anymore.
Okay, so you don't even need to like set it, do you? You don't even, don't even need to do what I'm doing. I will test that theory. Okay, so I guess I don't need to worry about it. Okay. Alright, alright. I'm getting a crank plate on me. I could have sworn. Character. Okay. Okay, I'm getting pranked. What? Sick fucking prank, bro. Collision enabled. Okay, did he set some simple collision on there somewhere that I missed? I kind of skimmed through the video.
Subtracting box print all these. So isn't as good if there's no clear box, because it won't get cleared every read of this box's dimensions to subscript, which is going to set that for the seed. Now if we jump, or exactly what seed public. In the construction script, we want to do them, you know, at certain times. So we're going to add a function called event graph right. So where's our bounding box? 5, 75, and 100. So I figured these out with a little bit of trial and error. We're going to split the structure dynamic mesh now.
Okay.
Set the operation to typing too fast can release all compute meshes. Oh, but that is what's going to be thing, right, as we drag this box around. So what we could do to test it.
I wonder if, like, is there something to, like, what other things are in here? Oh, I guess. Go back to the video.
We've got a character here in a wall.
He just like added.
But then parts of the wall are going to start disappearing because I'm Boolean subtracting boxes out of them. That's what we're going to miss. This time, instead of using generated dynamic mesh actor like we've used for all these previous tutorials I've done, we're going to use the base dynamic mesh actor. So generated dynamic mesh actor is for in editor, and dynamic mesh actor is what you have to use if you want to do things at runtime. And that's because you have to manage the mesh yourself. So we're going to call this BP wall with holes. I've already made one. That's what I just showed. So we'll make another one, and hopefully I remember all the steps. So the basic thing we're going to do is make the wall. So we're going to do that in the construction script. Now in the generated one, we don't use the construction script. We use that rebuild mesh event. But for the runtime version, we have to use the construction script, which
that's what he was doing.
Isn't as good in the editor, but it's variable. So we're going to get it ourselves from our component. We're going to reset the mesh. You have to explicitly clear it because it won't get cleared every rebuild like it does with the rebuild generated mesh event. And then we're going to append a box. And I'm just going to set this.
Does that have collision on it then?
This box's dimensions to some numbers that I figured out already. And then we're going to do one more thing in here while we're here in the construction script, which is make a random stream, which is what's going to generate those boxes. And we're going to set that random stream to a new random stream, and we will add a variable for the seed. Make that an integer, compile, set that to 37 because I know that's a good starting seed. And there we go. So that's all we're going to need in the construction.
Okay, so I guess this append box function handles setting collision or something. What? Mesh primitive functions, append box, okay. Simple collision, yeah. Okay, so it does... It does handle. It just, okay, it just adds a box element on it. I mean, maybe I should just do that instead of like computing what I am. But this works for now. Okay, so that kind of answers the collision issue. I still need to calculate the verts, which is what I was talking about before, which was the direction of the triangles. I have to calculate those in a specific way. And I was trying to figure out whether or not I wanted to do an unbounded Z grid or not. Like, should I have a single terrain chunk in per Z column? Like, just have an not infinite, but like theoretically infinite 3D grid or chunk that just goes in the Z direction in all forever, you know? Or should I have Z chunks? I would need like a min and a max. And definitely will have to be something I figure out off stream because it's very, very complicated. And I'm trying to, does that need to be a separate dynamic mesh? I should probably just figure out how to like, I should probably just try to like do the 3D Perlin noise algorithm. Just figure out how to get that working. Let's get rid of this test. Force delete. Now we know that it works. Where's that dynamic mesh test level? Yeah, get that out of here. We know it works now. Okay. Yeah, I think first step is maybe to just get the 3D algorithm working separately, or at least get one of these little pockets of 3D space to get generated. I think that's probably the next step. Just out of curiosity, are there any videos on that? What other videos do you have, Ryan? Point arrays. Let's look for like Unreal Engine Dynamic Mesh Perlin. I'm just gonna put in Perlin. What is this?
It's not a hobby.
Hello everyone. So today I'm going to introduce you to the dynamic mesh component and geometry script plugin. So the reason that I'm doing this is recently we worked on this world generation system, and here we generate the landscape using procedural mesh component, and I got some suggestions from various people that dynamic mesh is more performant compared to procedural mesh component, so we are going to find out. So but before we get started with this, we need to know the basics of dynamic mesh
so
components.
He said people told him dynamic was more performant.
This plugin and do some simple operations in that. So after that, hopefully we would have a better understanding on how to approach creating dynamic.
Tell me the outcome.
See. Okay, so yeah, those are the things you can do. This surface, then we can increase the tessellation or 1000 minus 1000. So let's make geometry script mesh selection. Oh no, that doesn't seem useful. Yeah. Oh, let's try select. Oh, select mesh elements in a box. Oh, now we can. Let me navigate. Right. So if I increase the magnitude, we got a plane. Now, here, if I add noise, here we can add.
Oh, there's literally a Perlin noise node. Are you fucking serious?
And compile. Now you see there are some noise on this plane. Okay, now let's explore some more options here. So other than Perlin noise, here.
Odd, weren't you talking about the other day, like, you know, the good thing about streaming is like someone comes in and tells you there's like a system built in for like the thing that you're like completely writing or rewriting.
We should have some other deformation options as well. Here, you can see all
But to be fair, Geometry Script came out 2 years ago. And a little over 2 years ago is when I started working on this, so.
Apply bin wrap, apply displays from per vertex vectors. A lot of stuff are there. Okay, now let's see.
Wait, what were those?
Vector.
Apply displays from per vertex vectors. Apply flare warp. Fun.
Yes, a lot of stuff are there. Okay, now let's see how these options work. Let's make geometry script Perlin noise options. So here, apply along normal. We can enable or disable that. And base layer. Let's look a bit into that. Let's make base layer. Okay, here you have magnitude, frequency, frequency shift, random seed. Right. So if I increase the magnitude, you should see larger deformations on the noise like this. See? And if you change this frequency, let's make it 5. I think if I increase this, we should have more fine-grained details. Let me enable wireframe mode. Okay, if I decrease it, let's see what happens. Yeah, see, we barely see any change. So yeah, as I increase the noise, we do get more noise, more small scale noise. Like this. Okay, now, if I make this large, instead of 1000, I'll make it 10,000. 10,000 steps, 1000. Compile. Now we have a larger, more like a landscape. Let me go to the lit mode. Okay, here if I
it's so quiet.
Mesh, material, yeah, it's more clear now. Okay, so now if I add another layer of this palette noise, let me do this. This is, I disconnected this because when I keep it connected and when I try to make changes, I think it's trying to update in the real time. Yeah. So it becomes a bit laggy. So what I wanted to do is, if I add 2 layers of Perlin noise with 2 different frequencies, here we should make 1 if I make it, which is not exactly what I expected. But now you see the noise 0 1, and make sure to connect this target mesh. Oh, we got something like this, which is not exactly what I expected. But now you see the noise is applied, and in the wireframe mode you can see some weird mesh. Okay, now let me disconnect this, and now let's make a sphere. Append sphere, sphere box, sphere lat long. Let's choose the first one, whatever that is, and here radius, so just 500 or 1000. Steps 6 by 6, 10 by 10 by 10. Compile. Okay, now we got a sphere. Right, now to this sphere as well, we can add Perlin noise. Do we see any difference? Did I connect it? Yeah, correctly. Yeah. If I go to the wireframe mode, yeah, just like before, if I apply some magnitude and compile, now you see deformations on this sphere. So
I wonder if what I should do is just like, for the underground parts, just create a box and then subtract like the 3D noise globs out of it, and it'll just like create the verts and stuff for me. It's like creating, you know, some probably unnecessary draws or something, but like from a code perspective, that would be very easy for me. I don't know, how would you create, like, essentially what I would want is like an inverted sphere, right? I'd have to like flip all the triangles or something.
So, more like a natural planet maybe, with high mountains. Okay, now, here you see, let me show you something else. So what if we want to increase details of only one section? So perhaps in a box. Oh, now we can, this, let's should see into same select node. We would work now because there are additional triangles here after applying the tessellation. So I think we may have to have a different selection, but anyway, let's see what happens. Yeah, see, it's not working as expected. So we may have to do another count sphere without it. Here in warp the dynamic mesh and play. What is dynamic mesh is done in my channel from my Patreon page. Feel free to check it out. That would help me to continue what I do in my channel. And see you in another episode.
Yeah, because like essentially Unreal Engine, let's do dynamic mesh concave. Still collision meshes. I mean, you can have concave, but I guess I just don't know how to create that in my head. Like, what? I mean, I guess I can pass the verts and just like I was saying before early in the stream, I have to like check what direction each vert is in relation to solid ground versus open space. Checking these values and stuff. I don't know, first pass might be just like create box, subtract everything out of it. And so like it would, like the underground would actually be kind of like filled in to a certain aspect. And then how would I subtract? I'd have to build this shape. I'd still have to build the shape. I think I still have to do that same. The empty spaces will start as filled in, but then you flip the normals. I mean, I'd have to flip the triangles as well. That's the kind of difficult part. If I just create like a box and then subtract whatever this shape is from it, then it's, you know, rendering extra. Disclaimer, I have no idea what I'm saying. Yeah, you'd have to flip the normals and essentially flip the triangle. Like, you'd have to regenerate the triangles, essentially. Because the triangles, you have to, like, I'll show you here. Like, the triangles, you have to add to tell it, like, which... That's what tells the mesh which way it's facing. And so for each vertex that you have to add the indices of that vertex to the triangles array in a certain order. And so to like flip it, yeah, you'd have to go back through and do that. Yeah, I'm gonna have to come up with a shape one way or another, regardless of which way it's facing. So I don't know, maybe the subtraction method isn't worth it. Well, the subtraction method would be good for future subtracts. The GPU draws triangles at a specific order. Yeah, right, exactly. I think it would actually be kind of cool to like build each chunk is a mesh, like an actual, like an entire mesh. And then as you dig, you're just subtracting from the mesh and potentially the mesh next to it as well. That would, from a code perspective, that would be the easiest. It would not be the most efficient. And I wonder if I could just have the compute meshes not actually rendered and stuff. Yeah, that's gonna have to be something I explore off stream. That's just gonna take a massive amount of tinkering. Should I try and do, is that what I should do next? Or should I work on the shader part? I mean, yeah, maybe I should just try that and see how it goes. Well, this has been a very exploratory stream. Didn't that make any actual progress on anything other than... like, I did find out dynamic meshes work, which is great. And they're quite performant. But I was sleeping on them, apparently. Yeah, that's cool. Let's I'm gonna hop off here. I've been streaming for about 6 hours, so need a break. Probably gonna do some stuff off stream. Then maybe, you know, all goes well. When I come back, I'll have a 3D Perla noise terrain algorithm working. Fingers crossed. We're gonna raid Finn, so tell him I said hello. Thanks everyone for stopping by. Appreciate your time and eyeballs and hanging out with me. And I hope to see you next time. Gym time, baby. Hope my crush is there. I hope for you as well. Good luck on that. Bye, guys.
How's the metadata?
Bird!
My drunk! How you doing? Oh yeah. Oculus. I'm my drunk. What were you up to today? G'day guys. How you feeling? How's things going? Guys, you want to check out my drunk? He's also an Unreal Engine developer. He's doing some very smart